Bugün bir takım konuşmalar olacak. Moderatör olarak karşınızdayım. Öncelikle ben de teşekkürlerimi iletmek isterim. En önemli teşekkürü içinde bulunduğumuz kuruma, Sabancı Müzesi'ne teşekkür etmek istiyorum. Sakıp Sabancı Müzesi'ne. Anlayışları ve bu konunun arkasındaki duruşları açısından da çok önemli bir şeyi başardıklarını ben bizzat gözlemliyorum. Ve bunu da birlikte devam ettireceğimizi hissediyorum. Bugünkü konuklarımıza ayrıca teşekkür edeceğim. Onun yanı sıra da bir şey itiraf etmek istiyorum. Aslında bu, ben teknolojik sanat eserleri üreten bir sanatçıyım. Bu aslında benim kişisel bir de meselem. Bu da benim için bir dert olduğu için aslında Osman Bey'in daveti neticesinde Mayıs ayında bir konuşma yapmıştım. Bu konuşmada bilişim çağı teknolojik sanat eserlerini nasıl koruyacağımıza dair ne kadar çaresiz olduğumuzu biraz olsun göstermek istedim. Oradaki tutumum bir sanatçı olaraktı. Çünkü çeşitli koleksiyonlarda sanat eserlerim var ve o eserlerle ilgili kaygılarım da devam ediyor. Her şeyin ötesinde koleksiyonlarda olan eserlerimden bir tanesini tekrar sergilenmek üzere İtalya'daki bir sergi için kendim restore ettiğimi de biliyorum. Yaptığım sergilerde dahi kullandığım teknolojiler sadece birer ürün olmaktan öte aslında eserin parçası olmasıyla beraber onların temsiliyeti ve eserdeki anlamını da sanatçının biçimlendirmesi gerektiğini düşünüyorum. Tüm bu konuşmaların ötesinde projeye dair de size biraz daha çağrı metnini sunacağım, okuyacağım hatta. Çünkü bir yılı hedefledik. Bu bir yıl neticesinde çeşitli konuşmaların ardından da arzu ettiğimiz çok önemli bir şey var. Farklı kültür kurumlarını, sanatçıları, koleksiyonerleri, müzeleri, galerileri, bu alanda çalışan çünkü yani bu paydaşlar aslında bu sektör içerisinde son derece yoğunlar ve hepimizin öyle bir gündemi var ki bu yoğunluk içerisinde birbirimizin etkinliklerine dahi gidemez hale geldik. Fakat bir konsorsiyum yaratabilirsek hem görüş birlikteliklerimizi hem de görüş ayrılıklarımızı bir araya getirebilir ve konuşabiliriz. Çünkü konu aslında çok da sanat özelinden çıkabilir, gündelik hayatlarımıza da sirayet edebilir. Bugün cep telefonumuzdaki eşimizin, dostumuzun fotoğraflarını nasıl koruyacağımıza dair bile kendimize dair verebildiğimiz net yanıtlarımız yok. Çoğu arşivlerimiz kayboluyor. Ama tabii ki onlar kişisel bir takım meseleler halinde yok olabilirler ama biz bir miras korumak zorundayız. Bundan belki de 100 sene sonra benim kendime sorduğum soru bu oldu zaten. İlk koleksiyona verdiğim eser sonrasında 100 sene sonra ben olmadığım zaman bu eser ne olacak? Nasıl bir temsiliyete sahip olacak ve bunu kim koruyacak? Ve bunun bir karşılığını da göremediğimi fark ettim. Ve yani sanatçı olmaktan öte bir yandan da Sabancı Üniversitesi'nin akademisyeni olarak bu sorumluluğu üzerimde hissederek müzeyle birlikte bu işbirliğine girerek herkesi davet ediyoruz. Özellikle bir çağrı metni hazırladık. Şimdi size onu okumak istiyorum. Öncelikle motivasyonu söyleyeceğim. Üretilmesi teknolojiye dayanan video, ses, imaj, kod, sanal gerçeklik, artırılmış gerçeklik, kinetik, sayısal ve fiziksel melez birliktelikler gibi ve çalışması için teknolojiye ihtiyacı olan yazılım, donanım gibi sanat eserleri artan bir eğilimle çeşitli sanat koleksiyonlarına dahil ediliyorlar. Bu tür sanat eserlerinin hızla değişen teknolojiler karşısında geleceğe nasıl taşınacağı ise kültürel mirasın korunmasında sorumlu olan tüm kültür kurumlarının yüz yüze kaldığı zorlu bir mesele olarak ortaya çıkıyor. Kapsamımız ise şu, bu motivasyonumuzdu. Sabancı Üniversitesi Teknolojik Sanat Eserlerinin Korunması başlıklı araştırma projesi kapsamında konunun paydaşları olarak sizleri değerli düşünceleriniz ile projeye katkı yapmaya davet ediyor. Bir sene sürmesi hedeflenen proje kapsamında zaman zaman düzenlenecek çeşitli panellerin yanı sıra konu üzerine çalışan çeşitli sanatçı, küratör, koleksiyoner, akademisyen, kurum ve kültür yöneticileri gibi kesimlerden elde edilecek görüş yazıları derlenerek bir e-kitap yayını ortaya çıkarmayı hedefliyoruz. Amacımız teknolojik sanat eserlerinin korunması için tüm paydaş kurumları bir araya getirmek, konu üzerindeki görüş birliklerini, daha önce de belirttiğim gibi ve ayrılıkları bir araya da konuşabilmek ve ortak bir konsorsiyum oluşturmak. Projenin bu aşamasında arzu ediyoruz ki bu proje bir yılı sonrasında da daha da büyüyerek gelişebilsin. Fakat şu anki kapsam içerisinde belirlediğimiz 5 tane tema var. Tema 1, yazılım kullanan sanat eserlerinin korunması. Bugünkü panelistlerimiz zaten bu konu üzerinde görüşlerini belirtecekler. Tema 2, web arşivleme ile teknolojik sanat eserlerinin korunması. Yine bugün bu konuda bir takım cevaplar arayacağız. Tema 3, internet sanatı ve eserlerin korunması. Tema 4, teknolojik sanat eserlerine yönelik medya arkeolojik rekonstrüksiyon. Tema 5, teknolojik sanat eserleri koleksiyonu oluşturma, eserlerin sergilenmesi ve korunması. Dediğim gibi bu genel çağrıyı burada özellikle belirtmek istiyorum. Daha da spesifikleşecek bu çağrı. Yani çeşitli paydaşları burada görmekten ciddi anlamda mutluluk duyarız. Kimseyi dışarıda bırakmak arzusunda değiliz. Herkesin bu konuyu üstlenmesi gerektiğini düşünüyoruz. Yanı sıra da 3 adet aslında belirlediğimiz rol söz konusu. Bunlardan birisi, eğer bu projede katkıda bulunmak isterseniz bize ulaşıp şu rollerden birini edinmeniz mümkün. Panel konuşmacısı olmak. O da bugün göreceğiniz bir rol. İkincisi ise çok kıymetli olduğunu düşündüğüm bu yayın meselesi, e-kitap meselesi. Orada da bir akademik görüş yazısı toparlamaya çalışıyoruz. Neredeyse 5-10 bin kelime arasında bir yazı peşindeyiz. Durumun ne kadar muammalı olduğunu farkındayız. Herkes bir böyle elini taşın altına koymasının noktasında geri adım atar gibi, ama ben cesaretlendirmekten yanayım. Lütfen bana ulaşın ve konuşalım ve bu meseleyi en azından ele alalım arzusundayım. Hiçbir şeyin doğrusu veya yanlış olduğu gibi bir yerden yola çıkmayacağız. Öyle gözüküyor ki daha çok analiz yapacağız. Ve zaten 3. rolde bunu aslında üstleniyor. Belli bir eser hakkında teknolojik sanat konservasyonu üzerine örnek çalışmaların yapılması, stratejilerin oluşturulması ve temel ilkelerin belirlenmesi. Bunu da bir yazılı bir rapor olarak talep ediyoruz ve bütün bunları bir araya getirerek bir kitap yayınlama peşindeyiz. Durum analizi demişken yarın da bir workshop yapacağız. Yine teknolojik sanat eserleri yapan Candaş Şişman'ın bir eserini buradaki katılımcılarla beraber Patricia'nın önderliğinde yapılacak workshop'ta restore etme yöntemleri, prezervasyon için çeşitli stratejiler kurmaya çalışacağız. Proje ekibini de biraz söylemek istiyorum. Aslında 2 kişiden bahsetmiş olduk. Osman Serhat Karaman, burada dijital koruma uzmanı, Sabancı University Sakıp Sabancı Müzesi'nde bulunuyor. Bunun ötesinde de disiplinler arası tutumumuzu da sergilemek açısından çok kıymetli olduğum diğer meslektaşım Cemal Yılmaz Hoca buradalar. O da bilgisayar bilimi ve mühendisliği alanında. Eminim sürprizlerle dolu şeyler duyacağız ve bu disiplinlerin bir araya gelmesi çok kıymetli. Bir yandan da ben de görsel sanatlar ve görsel iletişim tasarım programını temsilen projenin yürütücüsü olarak 3. şahıs. Şimdi programa başlayacağız. Bu uzun girişten sonra ilk panelimiz Conservation of Software-Based Art içerisinde ilk Patricia ile başlayacağız. Patricia Falcao, Preserving Digital Art at Tate isimli konuşmasını yapacak. Şimdi biraz İngilizceye geçeceğim ve hakkında size küçük bir giriş yapacağım. So her speech is about, the title is Preserving Digital Art at Tate. And Patricia is a time-based media conservator with a broad interest in the preservation of the digital components of contemporary artworks. And she has worked at Tate since 2008, and currently she works in the acquisition of time-based media artworks in the collection. So let me invite her, and she'll do the rest of the introduction.
So, hello, good afternoon. As Selçuk said, my name is Patricia Falcao, and I'm a conservator at Tate. I also need this. I think I must be very clear to start with. I'm a conservator, and I trained as a conservator for furniture to start with, and now I ended up here. I've learned to read code a little bit because I needed to. I'm not a programmer, and I'm not a software developer, so it's not a requirement. And I always have this little bit of the, there's this, where you always feel that you don't know enough, and now over the time I've learned, actually, I don't know programming, but I do know quite a lot. So I hope yeah, I'm waffling now. So, as I said, I'm a time-based media conservator, and at Tate, we have a very large conservation department. I think there's about 50 people between conservators and technicians that deal with all the different media, so from paintings and sculpture to paper. And we've had a section dedicated to time-based media, which we define as film, anything that has the aspect of time, so film and video, software, performance, if there's people involved, and then light boxes for historical reasons. And so the team I work in is probably one of the largest time-based media conservation teams in the world. And we're one of the earliest departments. So we've had somebody looking specifically at this subject since 1998. And we've had a separate section for this for a long time as well. So what you're seeing here is sort of this distillation of our processes over time and going from fairly simple objects to fairly complex. So it's not, I don't think it's an easy process. And when I came to it, it was already halfway. So this is the result of a lot of people's work. And so, as I said, I'm also in Tate, which is this very specific institution. And because I've been there very long, I also have a very narrow view of the context. So if let's say it's this whole context is fairly narrow, so it's worth questioning it if you have any questions. I think what's important for me is that it's actually on Tate's mission. So this is what the government approved back in the 70s, I think, was that this is what we need to achieve. And this is to care for, preserve, and add to the works of art in our collection and the archive. And I only work with our art collection. There is the archive as well, who also has their own digital challenges. But they're a separate section. And the other thing that is really important is that we need to ensure that our works of art are exhibited. And for a painting or a sculpture, this is obviously, you know exactly what's going to happen. And with time-based media works, the fact that you have to exhibit something means that you have to do more than just put it in the gallery usually. What this means, because it's here, is that I also have quite a lot of leverage in asking for resources and justifying the time that we need to research things. Just to give you a sense of our collection, this illustrates the whole of the Tate collection. There's about 80,000 entries, but I believe this blue, dark blue, is just William Turner's work, painting and sketches. Every single page of Turner's work has one number, so that's how they show up in the collection. This is everything else. And the yellow is time-based media, so all the film and video and everything, digital basically. And then what you don't see is like there's this little sort of slightly wider black line, and that's the software-based artworks. And that line represents this, and there's 3 more works that are in the process of coming in that are not listed here. But this is the whole collection. So what this means is that, you can see a few things. You can see that the first work was acquired in 2003 and was also produced in 2003. In terms of software-based art, this is fairly late. I mean, it's using Windows XP. So looking at the people that I see in this room, you probably all worked with Windows XP, right? At some point. Maybe some of you haven't, but... and then you can see most of them were bought shortly after they were produced, with a little exception. And also, there's like one every other year or so, until 2015. And then in 2015, or 16, we had a change in the director at Tate Modern. And she said, well, we're going to start investing in digital art, which means software-based art, basically. And so what we are seeing now as a result of that decisions in policy is that the number of works that we are acquiring has increased. And so right now I'm working on 3 artworks that use software as a medium, and that means a lot more resource. So, and this is not going to become less. We're going to have more and more works, more and more complex works, basically. So we need to step up what we've been doing. So this is becoming the earliest work in the collection. It's by Michael Craig Martin, who is actually, I think he started as a graphic designer, and his work is a lot about drawing. And what he did is he worked with the developer to create this animation. And the software element is basically just creating some randomness in how these images appear and disappear. So you can see this one is becoming transparent, and then with time some will appear and disappear. And it's meant to hang in the gallery just like a painting. So you could have it in the gallery next to his drawings, for instance. This is, for a long time, was the most complex work in the collection, and now it's not anymore. It's an interactive installation by Raphael Lozano-Hammer called Subtitled Public. And what happens is you go into a space, a dark space, and there's nothing there other than other visitors. And you have a word projected on you that says eats or sleeps, something that also works as an identifier. And then it follows you through the space, and if you don't like the word, you want to get rid of it, and if you come close to somebody else, then you swap words with that person, in theory. There's 50% chance that happens, actually, looking at the software. But so the theory is you swap words with the other person.
Patricia, I realized I haven't mentioned about the Q&A. Oh. When we discuss, it could be an interactive presentation. So if you have any questions, please address.
Oh, sorry. Yes, I meant to say that. But so feel free to ask any questions. So what did I say? Yes. So it sort of lets you. That's what it does. It follows you in the space, and you're meant to swap words. This is fairly complex in that it uses a network of computers and cameras and projectors that need to talk to each other. You need to track the space. You need to find where people are in the room. So it is fairly involved, not just the software itself, but also how you install it and the calibration process to make it run correctly. And this is another piece by José Carlos Martinat, who's a Peruvian artist, called Brutalismo. And it's actually based around, this sculpture is a model of the Pentagonito, which was the headquarters of the political police in Peru, I think. And the work was also firstly shown on this brutalist gallery in Brazil, Galeria Leme, which is in this brutalist building. So what the software is doing is, if you see, there's this computer here, and it's searching the internet for words around brutalismo as an architectural term, but also related to dictatorship and political violence and all sorts of, and then it actually is looking just brutalismo and related terms. And it was very much looking at South America, and then we brought it to London. And I'm Portuguese, so the words that we're searching for in Spanish, so brutalismo is the same as Portuguese. And so when we started testing it, we started seeing results about Portugal and Portuguese dictatorship. And I was like, I'm not sure I'm meant to have this influence on the artwork, that it's just talking. And so we talked to José Carlos and said, well, it's going to be in Britain, so the results will be different, and it's Google, so we don't really have much say on that. And he was like, no, it's fine. It should move with the times, and if you get different results, that's fine. But that was sort of a moment where I was like, oh, I'm actually influenced something that I can't not influence almost. And so that's not what I meant to do. So you have this computer, and then it sends sentences to these printers. And so you have sentences related to the search terms coming out in these little pieces of paper. And so when I first started looking at software-based art preservation and thinking, it was in 2008 for my MA thesis, and this was sort of what I came, why do we feel that this is such a different subject, or problem. And I think the one point is that these systems are bespoke. So for the works that you saw on that list, we have probably, I think we have 4 different operating systems and 6 different languages, plus lots of different proprietary software that is used as well in combination with that. And so each one of them is pretty much unique. Some of them might have the same infrastructure, so let's say there's 2 running on Windows XP, but they are bespoke. Also, the other point is you can really change them very easily. Very often what you see as a conservator installing a work in the museum is that you come in and the artist comes in and his technician who developed the software comes in, and all of a sudden they've changed things. They made it all better, which is, you know, it's just a process that it is, but you need to be aware of that. And at first that made me sort of quite nervous because things were being changed and you're not meant to change things in the museum. And then all of a sudden it's like, no, you know, that's just part of the process, and you just understand the changes that are being made and document those, but it's fine to let other people change. And so again, with the change, the technological environment is changing. So I don't think anybody here will still be using Windows XP at home. So, oh yes, you are the examiner. But also, so the technology is changing, but also the tools and the possibilities for preservation are also changing. So I think there is a massive difference in what is possible now to what was possible 10 years ago. So what are we trying to preserve? And this is not as obvious, and I mean, doesn't have as an obvious answer as you might think. So I'll just show you how I think about it. So I looked a lot into the digital preservation world because we are learning a lot from them. There's a massive community all over the world working on digital preservation, and they've come very far in many subjects. So if you're starting, that's a good place to look. And they created this definition of significant properties, which is what you want to preserve. And this can be applied, for instance, for a spreadsheet. And if all you need is the content of that spreadsheet, as in the results that you see on the spreadsheet, then you can have, you know, a static text file that recreates that. But if you want to know the calculations that are used to create the numbers on that spreadsheet, then you need to do something else. And for artworks, it's the same, but with another level of complexity. So what I did was I just stole their definition, and instead of saying digital assets, I say artworks. And what that does is explode outside of the digital world to the whole artwork, or at least that's what I hope it happens. And the other point here is that you need to think, if you're thinking about digital preservation, you need to think about accessibility. So if you have a box in the attic, it's not really accessible. And for us, accessibility is about putting stuff in the gallery and displaying it. And usability, so being able to use it and reuse it, and their meaning. So this is sort of, it doesn't answer the question completely, but it just so you understand where I'm coming from. So these are the parameters I usually think about when I'm looking at an artwork for the first time. And so if you look, it usually starts with the media or the software or the data, which comes, you know, in a memory stick or on the computer somewhere. You know, and you can usually like see it like on your computer. And that is sort of the core. But then you also need to think, okay, I'll need to play this back. And I use playback because I mostly work with video. I don't know if it would be the right term to talk about software, but it's the same idea, is that you need to be able to run the software as well. And that's usually not very unique. So we use a lot of these little NUCs, for instance, and we use them for everything. But then you also need to think about the display equipment. So is there a projector showing some images, or is it a projector actually just showing you words, or is it just a printer? Is there a screen or a monitor? So what sort of equipment are we talking about? And then last but not least, you have the display space. And for many of our installations, you need to have a lot of other information to really understand what an artwork is. So in this case, this is a plan for an installation. And you have these files here, and in the end, they need to be displayed in the space like this. So that's, the first projection is there, the second projection is there, the third projection is there. So it's a lot of things that you need to bring together. And the other thing is, depending on your artwork, these conceptual elements can have different weights. So in some cases, all you need is your media. So if you have a video work, you have a video file, and it's meant to be shown in a monitor or projected, but what you need is to show the content of the video. And so really what you need to preserve is this. But if you have something like a Nam June Paik artwork, it can be that some of these aspects, specifically the display space or the display equipment, have conceptual value. And in that case, you need to adapt your strategies to accommodate that. And so this is sort of what I think when we first do an assessment of an artwork. And that moment is here. So this is how we think about the life cycle of an artwork in the Tate Collection. So the artworks are produced here, or sometimes there, depending by the artist. And by the time they come to us, they've usually been shown a few times at least in different environments. So there's this history before it gets to us. And then Tate has a very strict procedure about or process on how an artwork comes into the collection. So curators propose artworks, and then before the final agreement is given, they contact us and we create this risk assessment process. And that is this acquisition moment. And at that stage, we do that risk assessment. We plan the preservation for the longer term, and we create a series of reports that I'll talk about in a second. But so this is the overall aspect. So you start with an acquisition, and then the work either goes into storage or it goes on display. That's still not the most common. Usually an artwork will come in and be stored for a couple of years and then is shown, just because of how exhibitions are planned with a few years interval. And then eventually you may need to do an intervention of some sort into the object. So this will mean it's often before a display, or if we are aware of some problem. And a lot needs to happen, sometimes happens at the acquisition stage as well. So I'll just say a little bit more about this moment, because it is a key moment. It's what you were saying at lunch, is actually when you need to have the information you need as early as possible. So if you know something is coming into your collection, that is the moment where you have the time to look at that. It's also, for us, it's a moment where we have a bit of pressure, because what we do at Tate is we won't pay for an artwork until we have all the information and the media that we need. So that means that there is an incentive for the galleries and the artists to give us information we need, because everybody's very, very busy, and so sometimes it can be difficult to do that. So it usually starts with a few emails, just getting a sense. Actually, no, that's not how it starts. Sometimes it usually starts with a curator sending us an email saying, we're looking at this work, what do you think? And then usually there may be a PDF with some details about the work, but usually there's nowhere near enough information to give an assessment. And so we use Google, of course, and find images online and try to figure out what an artwork is. And actually over time, we've become very good at just looking at a couple of videos or images and sort of making an assessment of what, no, really, you know, you like, okay, there's a video, there's 3 videos, there's might be sync or not, and so there's speakers, so there's sound, and you look at it, so you can get, I joke that we're little detectives and or stalkers, depending on the point of view. And so we do a lot of guesswork first, and then eventually we go to the artist and start asking these questions that we need for our initial report. And what I found is you need to do your homework, because if you can't go to an artist with a standard set of questions because they just get bored and then you don't get an answer. But if you come to somebody and you know what you looked at, so you have precise questions that they can answer quickly, that's a much better chance of getting a good answer. So I totally do not recommend forms to be answered, because it doesn't really work, or you don't get the information you need. So we ask questions about these 3 things. So we want to understand how an artwork is produced, what technologies are involved, who worked on it, you know, what equipment is necessary, and what they want to send us. So are they going to send us a computer with everything installed? Is it just an executable file on a USB stick? Is there any source code included? We want to understand that. And sometimes through this process we understand, what they're giving us is actually not enough. And it's not a big deal if we ask for something else at this stage, because they are getting all the data together. So if we ask now, we'll get what we need. And so the third aspect are the display requirements, which is also important at this point because it helps us understand the equipment we may need. And this is very informal. This is usually sort of 4 or 5 emails back and forth, depending on how complex the work is. And it is just a first step. So we then build on it as we receive the materials in-house. But the first step is just understanding what it is. So all of this is fed into this report that we fill out, which is in fact a risk assessment. And it's not very obvious here, but by doing this work, we are planning how we want to preserve it in the future, or at least what we need to do in the present so that we can preserve it in the future is actually the point. And also very helpfully, it tells our curators and our budget holders how much money they're going to have to spend to preserve this work. And then the other point is the result of the discussions about the displays that we create this document called display specification, which has all the information we need to display an artwork. And these are some of the examples, these are things that we try to understand. Bearing in mind that for many of these works, these things might change the next time a work is installed. So we try to create sort of a baseline of information, knowing that it will change when the work is shown or if anything needs to be done to it. And so this is what we are looking, this shouldn't be here. Oh, so at this point of acquisition, this is some of the things that we do for software. So we usually get 1 computer or 2 computers from the artist with everything installed and ready to run. I think that's because people usually prepare things to go into the gallery, so they want to have it set. And we assume that if it's on there, or, well, we don't assume actually because we test it, but the assumption is that the work is running as it's meant to run on that computer. And so the first step is just to create a backup, not a backup actually. The first thing we now do is it's to create the disk image of the original computer. And this was a fairly recent development that our My colleague Tom Hansen has done a lot of work into how we want to do this, because a disk image is basically a snapshot of that computer as is. So it contains all the information that is on the computer's hard drive. And you can correct me or explain in detail if you want. But, so that's sort of the first step. That means even if we can't access anything, we have that data. There's a few discussions on that at the moment. We're using RAW, but there's also EWF, which is the expert witness format or something. That is also, it's proprietary, so, but it has more metadata. And now I'm probably going to dip on that techie end. But so there's a few options that are still in discussion, but RAW seems to be a safe option. So that's the first step. And then we do a series of copies. So we create another hardware copy. So we buy a new computer and we install all the software. What we find is that by doing that, we often find things that, sort of, if the software uses a library and you don't have it, you won't have it on the computer that you've newly installed, so it will tell you that. And just the process of installing it means you learn more about the software and the system. It also means that you can have one computer in the gallery running, and if it breaks, you can replace it immediately. Which happens if you have a work running for 70 hours a week in the gallery. That's certainly going to happen. So the other thing we've done is to start creating disk images from scratch. It's much cheaper than buying a computer, and you learn, again, more about those dependencies that you need to care for. Yeah. And I mean, libraries are pieces of software that are not necessarily in your operating system and are also not part of your artwork software, but that you still need it to run. So they would be on the disk image. They would be on the disk image, yeah, but not if you are creating the new computer and you don't want to build it from the disk image. Oh, yeah. Then and then not from the disk image. Not from the disk image. No, we would install it from scratch. And also we then, sorry, okay. There's 10 minutes. And so you then have copies, and then we keep copies of the operating systems and the executables and libraries that we want as digital objects.
How about the hardware? Do you keep backups of the hardware, like hard disks, RAM, CPUs, or motherboards or something like that, or do you just keep them because most of the drivers of the image are...
No, we don't. Other than the extra computer, we don't keep any other, because in general they're not, you can move them on. So the fact that we create the hardware backup is more as a learning process, and because we do need something to move into the gallery, rather than thinking that is relevant. There is very little, none of our works is the hardware essential. They're all generic, so you can change it. With the exception of those printers that were shown, that we do have 20 of them in store. But so this is how our disk imaging report looks like. And I'll just sweep through. And this is the sort of documentation that we create at acquisition. So the production history, technical specifications, so what are the hardware, the software, any specific dependencies that we are worried about, versions and updates. And this is quite important, actually. The function of the artwork is just a plain language description of what the software is meant to do. Because if you are looking at something running, you don't know necessarily what it's meant to be doing. And actually what is missing here is, as soon as we have a chance, we video what the software is doing. Because it's really hard, if you haven't seen something working, you can't really know what it's meant to be doing and if it's doing it correctly. So I'll just jump through these bits, I think, and go through to intervention. So storage, this is how our storage looks like, and it's really essential. Sorry, this is not how our storage looks like, actually. This is how our storage looks like for objects. That's where I keep our... and this is how we keep our media. So we still have, we keep all our videotapes, and we have lots of hard drives that are staying there in the... And this is sort of where I wish we were with our digital storage. I think this may be a Google farm. It's not our servers. Certainly not our servers. Yes, so that is a current project that has been much more painful than we thought it would be. Is how to achieve archival storage for digital things. And the point for me at the moment in an institution is to explain to an institution that, if you spend thousands and thousands of pounds on keeping your objects safely stored, you keep your paintings, nobody discusses that if you have the budget, you need to have proper environmental conditions, you need to have your object well packaged, because if you're going to ship it somewhere, you need to care for that. And you need to know that your object isn't going to change in storage, and keep track of that as well. And what is hard to explain to the museum that has been doing this for hundreds of years, or maybe not hundreds, but possibly hundreds some, is that for digital you need to do exactly the same. And it needs to be exactly the same level of care, because our objects are digital, so you do need to have them safely stored, and you do need to have a good storage system, and it needs to be packaged properly, and you need to know that it's not going to change in storage. So it's not that different, and it needs to be at the same level of infrastructure of an institution, but it's really difficult to make the case for this. Also because it's not necessarily the basic IT. So our IT team is really good, really busy, but they care for the whole of our digital systems at Tate. So this is very little part of their work, and it needs its own set of skills. So if you have a small collection, then you might get away with a simpler system, but if you have a large collection, then you do need specific skills to care for that. So that's what I meant to say, is digital storage is storage. Cultural objects, they need storage. Good quality. And so moving on to the display, and this is something I very rarely do. I have very good colleagues that work on this, so other than saying that it is a moment where things change and you need to document that, I'm just going to skip through. That's what our reports say about that. And now the intervention. And that's where things change a lot usually. And like I said, it's often driven by displays. So if something is going on show, you may need to make sure your original computers are running, and you probably don't want to use an 8-year-old computer in the gallery, so you might need to move something on to the next computer. So that will usually trigger changes. And also these interventions often happen at the acquisition moment. Okay, I think I can. Thank you. So I sort of think of it as preventive intervention, which is when we first understand what an artwork is, we often have this discussion with the artist about, okay, we know that if your work uses a printer that connects via these cables, RS422, we will be in trouble to buy any printers that use this within the next 10 years. And so the conversation we had is, maybe if you can also give us the option to run it from USB printers, that will give us a few more years. And this is a lot of guesswork, so I may be completely wrong, and maybe in 10 years you still have RS422 and not USB. But, at least you're sort of spreading your risk into different options. And for instance, we have another work that was done in this gaming development platform called Unity. And the artist gave us an executable that runs on Mac OS. And then we had a conversation with him, and he was like, oh yeah, it would be very easy to just export something for Windows and Linux. And so he did that for us. So now instead of being dependent on this one piece, on this one operating system, we have an option of 3. So in the future, we have a few more options on how to deal with this work. And then at the other option is, or the other moment where you have an intervention is when something stops working. Or maybe before it happens. And so this is then what happens before the display, very often. So one example was for the Lozano Hammer piece. We shown it in 2009, and then we were showing it again 2 years ago in his retrospective. And there was a really interesting conversation in that we had been trying emulation in this really nice case study with Dragan and Klaus Reschert from the University of Freiburg, where we were using emulation, which was mean we were running the original software in its original software environment, so its original operating system, but in an emulator, so in a completely different platform. And so we were like, well, can we use this emulation to show the work again? And then when we found out, we prepared it for the display, and we had a few options. So we could either move it just to new computers and maintain the original setup, which was what we did in the end because it was the simplest option, or we could run it on an emulator, or what the artist decided then to do afterwards, which was just moving the whole software completely to a new platform. So this is sort of a very bad summary of the preservation strategies that we use, but you know it's picking up just on the storage. And I tried, I can't find a way to. It's like interventions doesn't work. So there's sort of two ways of addressing. There's multiple ways, but so you can think about emulation, which is this option that I'll talk about, and migration. And I have them as separate because they're different ways of intervening on things. But actually, I think in most cases you end up, or very often you end up having to use both in one way or another. So they're almost like different tools. If you're a paintings conservator, you wouldn't clean every single painting with the same solvent. You will choose which solvent is best for your work. So this is a little bit the same process. And then it's documentation. Again, it's sort of the overarching thing because you need to understand what was done, but also because it's so easy to change things, you also want to maintain, to at least have access to what was done originally and to understand how it has changed over time. And so these are the preservation actions that I was talking about. So we always start with the disk imaging, and then we find emulation is, in many cases, the most sustainable option because it would allow you to preserve groups of works instead of individual works. Because you are thinking, I'm going to steal Dragan's words over lunch, you are just thinking of the operating systems rather than the individual works. But then in some cases you do need to think about migration and interacting more with the software, the artwork software itself. And this is sort of an attempt at explaining a little bit better what emulation is. And so what you have here is the software environment. So this is what was on your computer when you first received it from the artist. So it will have your artwork software, but it will also have an operating system. And then it's talking to this virtual hardware environment, which is sort of, it's lying to the disk image to think that it is on the environment that it expects, that it's talking to the hardware that it expects. but it's not. So then you do have a layer underneath that allows it to then talk to whichever computer you have underneath. This is a very simple explanation. Well, I'm trying to do a simple explanation, but maybe it didn't quite achieve that. And then this is sort of an illustration of migration options. So this is the work Becoming by Michael Craig Martin, or a representation. And so the work was bought and existed as a computer. There was a version made in 2003, and then again another version in 2010, because the version from 2003 had bugs. And so we created a new version. And at that point we decided to use Flash, and now I'm kind of going like, that was not the best decision. But at the time it was sort of on the verge. We could have probably guessed it and so what you see is that there are multiple versions, and that we've moved, so you have one monitor and another monitor and computer, and then the individual files for each one. And so I guess I'll just, I'm over time, sorry. So these are what we try to do to improve our practice. And this one is, we do have allocated time for research, and we're very lucky that our research department has been involved in projects that meant they could give us time to do research and to find solutions. We're also training new staff, so our team has been increasing, and we spend quite a lot of time on training them. And we've started more and more working with other departments at Tate, so our technology department, curatorial, and Tate Media, which is not the default. I think we're quite unique like that, in that we interact a lot more. But also, we don't have the expertise in-house for most of the work, so we learn a lot from artists and their programmers, but also external software developers and computer scientists. We've had a few collaborations with universities, so I was very excited to see Cemal here. I think it's a great thing to have a software developer, a computer engineer? Scientist, sorry. In a conference like this. And then again, the digital preservation experts are excellent, and it's a really nice community to learn from. And then, of course, we also work with other museums and universities and digital preservation community again. And this is what we're looking for in the future. So I don't think this will ever end. We'll always do that because things change. So every few months, there's new tools coming up, and we want to learn about them. And we started thinking that maybe we can contribute to those tools. We haven't done a lot of that, but seeing the example at Rhizome, for instance, is, okay, we know what we need, so maybe we should ask for that and work with developers to do that. And then work in our collaboration within and outside Tate. And so that was it. Thank you. I'm sorry.
Thank you, Patricia. I will kindly ask the audience to keep your questions after the Cemal Yılmaz presentation. I've listed like 6 questions in here. I bet you have a couple more, but I think your questions could be boiled better when we are about to see the other presenters' presentation, which let me introduce Cemal Yılmaz over to the stage. Cemal Yılmaz received the bachelor's degree and master's degree in computer engineering and information science from Bilkent University in 1997 and 1999, respectively. In 2005, he received the PhD degree in computer science from the University of Maryland, College Park. Between 2005 and 2008, he worked as a researcher at IBM Thomas Watson Research Center in New York. And currently, he is an associate professor of computer science in the Faculty of Engineering and Natural Sciences at Sabancı University, Istanbul. And his research interests include software engineering and software quality assurance.
Thanks, Selçuk. So here we go. So that's me. Cemal Yılmaz, right? I'm a professor of computer science. My research interests include software engineering in general and software quality assurance in particular. That is to say that anything that can help us produce better, faster, cheaper, more reliable software systems is on my radar. Alright, having said that, here is the deal. Well, throughout this talk, in this talk, I will assume that we have software-based digital art, in the sense that, you know, in the creation of the digital art of interest involves the development of a piece of software system. Okay, so throughout this, I will assume that. So we are doing programming, we are developing a piece of software for the creation of this artwork, right? So this is interesting because if you really think about that, even in Turkey, we teach programming at middle schools, even at primary schools. That sort of suggests that it is inevitable that we will see more and more of software-based digital art in the future. Therefore, we should really start discussing how to take care of that digital art, right? So here we go. So as you can see, I'm a newcomer to this field, and I must say that I have so far read only a limited number of papers in this field. But one thing that I realize is that, you know, many of these works basically talk about preservation-related activities as activities that need to be carried out right after the artwork has been created. And in this talk, my ultimate goal is to convince you that this is something, like the preservation concern is something that should be addressed right from the beginning, right from the first day of the art project. Why? Here is why. Because it is similar to something that we as because it is similar to some of the very serious mistakes that we as software engineers used to do, right? For example, when it comes to software quality assurance, we as software engineers used to think that, well, it is something that we should do right after we have developed the software system, right? And it unfortunately took us years, and it took us thousands, tens of thousands of failed software projects to realize that that is not the case. We should really take care of take the software quality assurance activities into the account right from the first day of our software project. And I believe that preservation is not any different. It's no different than that, right? In the sense that preservation the concern regarding the preservation activities should be an integral part of the life cycle of any software-based digital art project, right? So that is what I will do. So that's what we should do during development, right? We call it development, during the development of this artwork or the creation of this artwork. So another question is, what should we do after the artwork is created? Well, there I strongly believe that we should regularly keep our software-based digital artwork up to date with the evolving technology, and we should do this regularly. So it means that we should, in a sense, since I'm assuming that software is involved here, in a sense, we should regularly update the software to cope with the changes in the technology, right? So why is that the case? Here's why we should do that. Because if we don't do this, in the sense that if we wait until the end, then the more we wait, the more technical debt will be accumulated, and the more accumulated technical debt, the more it will be difficult for us to preserve the artwork. Well, in this context, in the context of software engineering, technical debt is a concept reflecting the implied costs of additional rework caused by choosing an easy solution. So that means that every time you choose an easy solution, you are accumulating technical debt. And if you don't take care of that technical debt, at some point, it will basically go, right? It will basically go into the junk, and you have to restart everything. You have to start developing everything from scratch. Okay, so that's why I strongly believe that we should take care of this before we arrive at the age of disappearance of the artwork, and we should regularly update that. Another interesting thing is that there seems to be a lot of issues in this context that are familiar to us as software engineers, right? Many of those issues we as software engineers face in our standard, in our regular software engineering projects. And therefore, I strongly believe that we in this field can inherit many of the well-established software engineering principles, guidelines, tools, frameworks, approaches, techniques from the field of software engineering. As a matter of fact, what I'm going to do is that I'm going to briefly go over all those things that we can inherit from the field of software engineering very briefly. I'm going to discuss those things very briefly. And then interestingly enough, we have some problems. We have some really interesting and challenging problems, domain-specific problems specific to this domain, which can attract attention of the software engineering research community. And I'm going to also go over some of those problems and try to briefly explain them for you. All right, let's continue. So here is the thing that don't be alarmed with this picture. So here's the thing what I want to do. Well, in order to understand the source of the problem, I guess we need to first understand what is going on inside our computers, right? So I'm gonna briefly, very briefly, don't be alarmed, very briefly talk about the hardware and software stacks in problem, just to be able to, help you understand what the real problem is. So this is hardware. Here we go. All programming languages are compiled into machine instructions, and then they are executed. Those instructions are executed. Well, the hardware component, which is responsible for executing those machine instructions, is called CPU, which stands for Central Processing Unit. Those instructions, as well as the data that they manipulate, stored in memory. Well, this memory is called RAM, and in short, it stands for Random Access Memory. And the CPU and the RAM communicates with this thing called bus. Right? You can consider bus as a wire connecting the CPU to the RAM and the RAM to the CPU. And then we have all these I/O devices like keyboard, monitor, printers, hard disk connecting to the same bus so that they can communicate with the CPU and the RAM. Right? And everything is printed on a digital circuit which is called motherboard. So this is the hardware part, right? So hardware stays right here. So let's take a look at the software stack now. Well, in the past, when we were developing programs, software systems, we were developing them right on top of the hardware. That means that in the past, we were supposed to write our own device drivers for the CPU, our own device drivers for the keyboard, for the monitor and everything. And we had to do that for every system, every software system that we develop. And we have to do that from scratch. Then we said that why are we doing this every time from scratch, every time when we need to develop a piece of software? Why can't we hide the dirty details of hardware from programs running on top of the hardware? And we said, that's a good idea. Then we created an abstraction layer around that hardware. That abstraction makes the hardware transparent to the software, so that today when we are writing programs or developing programs, we don't really care about, unless otherwise needed, we don't really care about what type of keyboard is connected to the computer, what type of display is connected to the computer, because all those dirty details are hidden from us because of the operating system. Well, on top of the operating system layer, we have the application support layer, the goal of which is to hide the dirty details of the operating system from the programs. So it makes the operating system this time transparent to our programs. And on top of the application support layer, we have the applications, and our digital works will be in that layer, right? Digital works will be in this layer, and then we'll have like web browser, office software, and so on, right on top of the application support layer, right? Okay, let's take a look at the complexities of today's systems. Hardware, we have billions of transistors. Software, we have tens of millions of lines of code. Even we have billions of lines of code, like the code base maintained by Google. So, can you imagine how difficult to produce a piece of software? It looks like an insane task, right, to produce a piece of software, because we have billions of transistors interacting with hundreds of millions of lines of code, and still we as software engineers can develop software systems that do whatever we want them to do. It's like, an insane task, right? So here we go. How do we deal with this complexity? Well, simple. We use two mechanisms. One is the divide and conquer mechanism. It is very powerful because as software engineers or computer scientists, here's what we do. We divide a problem into sub-problems. We divide sub-problems into sub-sub-problems. Sub-sub-problems into sub-sub-sub-problems until the problem is easy enough to be addressed, to be solved by a single developer. So when every developer works on a simple problem, like a piece of the problem, then what we do is that we put those pieces together. And it is something like building, it is something similar to building with Lego blocks, right? We have the individual Lego pieces, we put those individual pieces together to create larger structures, we put larger structures together to create even larger structures, and we keep going on until we get what we want to get, right? And when we are doing this, we use abstraction. And that's to say that when we are putting these individual pieces together, we don't, as software engineers, we don't really care about the complexities involved in the development of these pieces. We don't really need to understand how those pieces are actually implemented. All we care about whether those pieces can be put together or not, right? And in order to put them together, their interfaces should match. So it is similar to building something with Lego blocks, because here is the deal. In order to put two Lego blocks together, well, their interfaces should match, in the sense that, well, in this particular context, you can consider the interface of a Lego block as the number and orientation of those bounds on the surface of a block, right? As long as they match, you can put two Lego blocks together. It is the same thing, the same story. As long as the syntax and the semantics of two software-based pieces match, we can put them together to create a larger structure, to solve a larger problem. Okay? Well, so far so good, right? Then what is the problem? Here comes the problem. Our artwork lives on top of this hardware and software stack. However, our artwork will have no control over this stack. Our artwork will have no control over these layers. And unfortunately, those layers may change, their interfaces may change, their implementations may change, the way they interact with each other may change, they may even become obsolete. When these changes cannot be accommodated, cannot be addressed, our digital artwork may disappear. And believe me, this is not a question of if, but when. Because there are many studies strongly suggesting that the biological half-life of software-related technologies is about 5 years. That means that any software-related technology that you use today in your digital artwork is likely to extinct within a decade or so, within a 10 years or so. Okay, so what we need to do is that we need to address all these changes in a timely manner to ensure a long lifespan for our artwork. So what I want to do is that now I want to go over some of the very simple techniques, the principles and guidelines that we as software engineers apply to our projects, right? So here is the first one. The first design principle says that anticipate obsolescence. This is a pretty well-known software design principle, which basically states that plan for changes in hardware and software platforms. So here you see some guidelines. Let's go over that very quickly and try to understand what they mean. Avoid using early releases of technology. Right? Why? Because early releases of a technology tends to have many defects, and in the presence of a defect, what we typically do is to implement a workaround. However, when those defects are fixed in the subsequent version of the technology, our workarounds may complete with those fixes, and then this may create an issue for us. Another guideline: avoid using undocumented or little used features or software libraries. So here we go. Here is the deal. So when things go south in software engineering projects, when, for example, the resources are scarce, software developers will ask these questions to themselves. Well, I don't have enough resources. I cannot support all the features I've been supporting so far. What if I stop supporting this feature? And to answer such questions, they will carry out an analysis which we call an impact analysis. They will ask themselves this: what if I stop? What will be the percentage of my end users that could be affected by that change if I stop supporting this feature? Well, if it is a little used feature, then the answer is very easy for the developers. Well, it's a little used features, I don't care about that, I'll stop supporting that feature from this point on. Well, if you end up using that feature in your artwork, you'll be in trouble. Another one: avoid using software hardware from companies that are less likely to provide long-term support. It is a bit harsh way of saying that do not buy technologies from small companies because it's harsh, I know that, but that's what it means. So because if they are here today, but they may not be tomorrow, and when if they run out of business, then who's going to provide you with technical support? Another one: use standard languages and technologies that are supported by multiple vendors. That is a way of saying that do not use proprietary technologies, because if you do, you will be stuck with a single vendor, and that's not good, right? Instead of using proprietary software systems, you may use open standardized systems, standardized technologies, or open standards, because in such case you will have multiple vendors. If you are not happy with a single vendor, or that single vendor, one of these vendors goes out of business, then you will have all these other vendors line up for you, right? So these are, simple principles. Oh, by the way, I forgot to tell you this, but I understand that the artists may not be able to obey these rules because they are artists. They have to be creative and so on. But I also understand that artists typically work with programmers or software engineers, and at least software engineers or those programmers can apply these principles. So here is also a related design principle. It says that design for portability. This is very important when it comes to preserving digital art, because this principle states that design your software system such that it can run on as many hardware and software platforms as possible. And one way to ensure that is to use cross-platform programming languages. So here is an example. Java is a very well-known, frequently used cross-platform programming language. Here is the deal with these languages, right? Regular programs are compiled into machine-specific instructions, and they are executed then by the CPU. Java, as a cross-platform programming language, is compiled into machine-agnostic instructions, which are often referred to as bytecodes. Then those instructions are fed to a virtual machine called Java Virtual Machine. And the Java Virtual Machine is responsible for converting those machine-agnostic instructions to machine-specific instructions so that they can be executed by the underlying CPU. That means that as long as you have a Java virtual machine implemented on a platform, developed for a platform, you can run your Java code on that platform. As a matter of fact, I don't have that. In the smart cards, we actually run Java virtual machines. Right? So, oops. Believe it or not, in here, we are running Java virtual machines. Right? That means that we can run our programs in here. Well, I am exaggerating because the type of Java programs that you can run here is actually a small and safe subset of the full-fledged Java programming language. But still, the idea is same. As long as you obey them, you can run them here. Okay. So here we go. So this is good. But another thing is that even if you are using like the cross-platform programming languages, you need to be really careful about not using any platform-specific libraries. As a matter of fact, if you want to create like a portable software systems, you need to use standardized interfaces as much as possible. So, for example, we have standardized interfaces for operating systems, we have standardized interfaces for programming languages, as well as for parallelization. So going back to operating systems, we have this thing called Portable Operating System Interface, in short, POSIX, which was standardized by IEEE. What happens is that if you only use this interface, this POSIX interface, to communicate with the operating system, then it means that you can easily port your system from one operating system to another operating system, supporting the same standard without any hassle. So the same also is true for the programming languages. For example, for C programming language, we have standardized interfaces like ANSI-C and ISO-C. Well, if you use those standardized versions of the C programming language, then it is guaranteed that your C programs will be compiled by all the C compilers out there which support this standard. And it is also guaranteed that the semantics of your programs will be preserved across platforms, across hardware and software platforms. So it is very crucial if you want to create portable software systems, and I strongly believe that creating portable digital art, which can work on as many platforms as possible, will significantly increase the chances of preservation. And these are important things. Well, here we assume that we know the dependencies, but remember that we are sitting on top of the hardware and software stack, and we don't really know what is going on in these underlying layers, right? Therefore, we are not necessarily aware of the dependencies that we create in our implementations. When we are doing programming, when we are coding, like developing a digital art, we don't necessarily know the technologies that we depend on, right? Because of all those layers of technologies, and we don't know what is going on in those layers, right? Fortunately, we can use static and dynamic program analysis techniques, approaches, which can automatically determine all the technologies, all the software libraries, all the software packages that our implementation depends on. And such a report, like you can automatically create a report, your system depends on this version of this library, that version of that package, this technology, and so on. Such a report can then be used for risk assessment. As a matter of fact, we have software metrics measuring or quantifying the level of portability that a software system has. For example, we have software metrics quantifying the direct portability of software systems, quantifying the installability of a piece of software, replaceability, adaptability, and so on. So we have all these software metrics, and I strongly believe that we can inherit those metrics from the software engineering field. And one interesting research question is that can we generate domain-specific software metrics, like like the preservability metrics for software-based digital art? Well, that's another thing, because like if you can come up with well, I'm just speculating. If we can come up with a, well, this we can. Next, whatever I will say next, I'm speculating. If we come up with a preservability matrix for software-based digital art, which will quantify the level of preservability the digital art has, then what can happen is that instead of doing that manual work, trying to figure out what the dependencies are, the museums can go ahead and in the blink of an eye quantify the preservability. And in the blink of an eye, then they can do whatever they want to do. They can, for example, I don't know, for the regions where the preservability is poor, I don't know, they can ask the artist or the programmer, well, let's make it more preservable. They can suggest techniques to the artist or the developers working with the artist to make it. They can even come up with like standards for accepting or buying digital arts. I don't know, that part is a speculation. Oh, by the way, the terms here, software engineering terms here, are given in orangish color. If you are interested, you can go, look them up later on, right? All right. So these are dependencies, right? Well, as software engineers, we don't like dependencies. So here is the deal when it comes to dependencies. As software engineers, when we see a dependency, the first thing that we ask is, can I get rid of that dependency? If we can, because sometimes accidentally you create dependencies. If you can, get rid of that dependency. If you cannot, the goal is to reduce the strength of that dependency. And at a very high level, here is how it is done. To reduce the strength of the dependency, rather than creating direct dependencies, we create indirect dependencies. And one way of doing that is to use software design patterns. Well, at a very high level, here's what they mean. It turns out that we have some recurring problems in software engineering. That is to say that we have some problems that are frequently faced in different contexts, in different projects and so on. But they are the same problems, right? So, well, in the past we were doing this. Every time we face a problem, like a recurring problem, we were solving it from scratch. Then we said, why are we doing this? Right? So then we said, why don't we figure out all these recurring problems and then provide efficient and effective solutions for each problem and document those solutions so that others, when they see the same or similar problems in their project, can adapt our solutions. Right? Those solutions are referred to software design patterns. Right? These are pre-formulated solutions for frequently appearing problems. And using software design patterns, right, is a way of learning from the experience of others, which is quite important when it comes to software engineering. In a facade module. And this facade module will actually play the role of an abstraction layer, hiding all the details, dirty details about these packages from the rest of the system. Only this module will be visible to the rest of the system, and the rest of the system will not be aware of the fact that these packages are already there. So here is the deal. So if these packages become absolute, or if these packages change, right, and you really need to accommodate the change, then hopefully all you need to do is to update your facade. And that update, all those changes, hopefully will be transparent to the rest of the system, because the rest of the system will not even know that these packages exist. Right? So here is, like I said, rather than creating direct dependencies, create indirect dependencies through an abstraction layer. Okay? Okay, well, we talk about dependencies. Okay, we know what dependencies we have. We reduce the strength of these dependencies, but it may still be quite difficult and quite expensive for us to put all those dependencies together. Right? In such cases, the best bet we have is to use virtualization technologies. And as a matter of fact, overall, I believe that this is one of the best bets that we have to preserve digital art, right? What is virtualization? So here's the definition. Virtualization is a process of running a virtual instance of a computer system in a layer abstracted from the actual hardware. So basically, just to help you visualize what it is, by using virtualization technologies, you can run multiple operating systems simultaneously on a single machine. So here is a Mac OS operating system. In one window, I am running Windows XP or Windows 7. In another window, I am running Windows 10. Yet in another window, I am running a Linux version, like a Linux variant. So right here, simultaneously, I am running 4 operating systems. 4 different operating systems. 1, 2, 3, 4, the host operating system. Well, when it comes to virtualization, it seems that we have 2 options to use. The first option is to use virtual machines, and basically a virtual machine is an emulated equivalent of a computer system. So you can consider each of these running in a virtual machine. Right? If this option is chosen, then it means that shipping an art, I don't know the word for that, sorry, shipping a digital art, you will ship your digital art, you will publish your digital art in a virtual machine, in which all the dependencies are pre-installed. So you will create a virtual machine, you will install all the required technologies, all the dependencies, all the libraries, all the packages that your artwork requires, together with the artwork itself, package it as a virtual machine and publish that. Give it to a museum. Then the thing is that that virtual machine can be executed on any hardware or any software hardware platform supporting the virtualization technology used. Then you can take it, run it on a Linux version, you can take it, run it on Arduino box or Raspberry Pi box, whatever. So this is the first approach. The second approach, an alternative approach, is to use virtual containers. Well, I don't want to go into the details of the differences between virtual machines and virtual containers, but at a very high level, here is what it means. A virtual container is like a lightweight version of a virtual machine, right? Well, the idea will be the same. You'll be publishing your artwork in a container, in a virtual container, where all the dependencies are pre-installed. Okay? One good thing about these virtual containers is that you can programmatically create them. You don't need to understand the code here, but here is what we are doing. I'm creating a virtual, in a sense, let me call it virtual machine. It is easier to understand rather than saying a virtual container. I'm creating a virtual machine where I install this Linux variant, this version of that Linux variant, then I create a user in that operating system, then I automatically install all these software packages, and finally I install Google Chrome. This is just a script, this is an executable script. When you execute this, the environment will be created for you in the blink of an eye. Right? Boom, boom, boom, everything needed will be downloaded from internet, and the virtual environment in which you're going to run your digital art will be created. Right? This is as simple as that. Okay, we talked about the dependencies, we talked about the environment, but obviously to ensure, you guys don't like this, but to ensure preservability, we need the source code of the artwork, not the source code of our dependencies. We need the source code of our digital artwork. And I'm not just talking about the final snapshot of the source code, I am talking about the history of all the changes made to the code base. Right? So, in order to keep track of the history of the changes, history of the code base, one technology that we can use is software repositories, right? We can use software repositories such as Git or SVN to do that, right? And in these repositories, the versions and the releases of our software should be clearly tagged. so that we can deterministically reproduce the code base. For example, we use in 2016 in the Metropolitan Museum of Art of New York, and we can then deterministically reproduce the other version of the same code base which we use in 2019 in Istanbul. Right? If we have these code repositories around, we can deterministically reproduce the code, and this is very, very, very important. It is not just about preserving or keeping track of the source code. We should also keep all the test cases around. So Patricia talked about it, right? Either accidentally you can create a change. You may cause a change in the behavior of the artwork, right? You never want to do that. So you take this, right? When you're installing it at a museum, after the installation, you want to make sure that everything is expected and that you did not change the artwork, right? Well, one way of ensuring that is to run the test cases against the artwork, right? Those test cases will verify and validate the behavior of the program, behavior of the software system, in this case, behavior of the artwork for you. Therefore, keeping the test cases, developing and keeping the test cases around is quite important. And from this perspective, we should exercise every relevant type of testing, like unit testing, interaction testing, system-wide testing, performance testing, and so on. Okay? And this is also important, all those test cases must be automated. And they must come with their own test oracle so that we can determine whether the test executions were successful or not. Right? So this test case should be push of a button thing. We should push after modifying, for example, after installing at the museum, or after performing some modifications to keep the artwork up to date with evolving technologies. We will run these test cases to see whether everything is expected or not. Well, speaking of test cases, this brings us to another pretty well-known software engineering principle, which basically states that design for testing and debugging. This principle basically states that you should take every step to make testing and debugging easier. So this principle basically states that you should design your system such that testing and debugging can be automated as much as possible. When it comes to design for testing, one thing that we can use is test-driven development. Well, in short, TDD. In test-driven development, what we do is that we come up with we develop the test cases first, even before we develop the software system. Right? Even before we start implementing the system. And for various technical reasons, this will help you come up with a software design, with a software implementation where testing can be automated as much as possible. And when it comes to design for debugging, one thing that we really need to do is to come up with highly cohesive, loosely coupled systems. Well, in particular, it means that we need to reduce the strength of the dependencies as much as possible. Okay, interestingly enough, when it comes to debugging, what is debugging? Debugging is the process of identifying and fixing bugs. When it comes to debugging, in this context, we can use really specialized debuggers. We don't need to use, on top of the regular debuggers that we have, we can use specialized debuggers. One such specialized debugging approach is called relative debugging. Well, in software engineering, we use relative debugging, especially when we are porting applications from one operating system to another operating system. So here is, at a very high level, here is how they work. You have this version of your artwork working correctly on Windows. Now you need to port it because that version of the Windows is gone. So that version, Windows XP, this version is, I don't know, Windows 10, right? So this version, you know that this version works, this version fails. You're doing porting, this version fails. Well, in relative debugging, what we do is this. We run these two versions in parallel. We freeze the executions at certain points and compare the internal states of the program, of these two programs, to quickly pinpoint the root causes of the failure so that we can fix them. And well, therefore, as you can see, relative debugging can play a very important role in preserving digital art. As a matter of fact, I strongly believe that domain-specific debugging approaches can also be developed in this context. Documentation. We talked about the documentation. Documentation is quite important because when worst comes to worst, the only thing that we can do is to develop the system from scratch, given its documentation. Right? That's the worst case scenario. Given enough documentation, we can hopefully, develop the digital art, recreate the digital art from scratch, right? By rewriting the programs and so on. Well, when it comes to documentation, we need to take a look at the software development processes. Well, here we see two software development processes at the extreme ends of the spectrum. On this end, we have the waterfall model. This is a plan-driven, documentation-heavy development process. Well, this process basically assumes that all the documentations must be developed before we can even start implementing the system. So we have to prepare the requirement specification documents, we have to prepare the design documents, and everything must be prepared first so that we can go ahead and implement the system. Well, unfortunately, this model does not support, it simply assumes that those requirements do not change during the development. However, in practice, the requirements typically, the things that the software system is supposed to do, typically change over time during development. And for such cases, here is the other development process at the other end of the spectrum. And this is called agile development, right? Such as Scrum. So agile assumes that the requirements will change. So the agile process will tell, what is the point of writing them down? They will change soon. Right? There is no point of writing them down. So what you should care about, when those change, you should go fix the program. So here is the two extreme approaches. When the requirements change, the question for the developer is this. Should I go ahead and update the documentation, or should I go ahead and fix my program? This model will tell, I don't know what to do. The requirement should not supposed to change. So I don't know what to do. You're on your own. This guy will tell you that, are you kidding me? Forget about updating the documentation. Fix the program, because it is what it matters. It is the thing that matters. Right? So here we have heavy documentation, there we have very little documentation or no documentation at all. Well, I suspect that agile development processes are a better fit for developing digital art. But unfortunately, there we will not have any documentation, little documentation. So here is the thing. It is said that in agile processes, the source code itself is the documentation, and that's another reason why we need the source code. So here the source code itself is the documentation. Okay? Therefore, in these processes, development processes, the source code should be kept as simple as possible. How do we achieve this? Well, here are some mechanisms. Refactoring. In agile processes, we frequently refactor the code. Refactoring is this. Refactoring is modifying an existing code base in order to make that code base more maintainable without changing the functionalities of the code base. So for a system, before and after refactoring, there will be no visible change from outside the system. But from inside the system, the system will become more maintainable. Another thing that can be used to cope with the lack of documentation is pair programming. That's also a frequently used strategy, right? We use technique to deal with the lack of documentation. In pair programming, two programmers, two software engineers sit together at the same workstation and do programming. One of them is coding, the other one is observing. They are talking with each other. Here, what should I do? What should we do now? Here, I am doing this loop. I'm creating this loop to do this and that. And they also discuss about possible corner cases and so on. So the good thing about pair programming is that it makes the knowledge of the code base shared by two developers, so that if one developer leaves, you will have this other developer which will have the knowledge of the source code. That's another way of dealing with the lack of documentation, right? Okay, we talk about documentation in natural language. We can also talk about like executable specifications. Not just documentations, specifications written in natural language, but we can also have specifications that are executable. Right? As the name indicates, executable specifications are like executable statements in the source code, the sole purpose of which is to validate the behavior of the program. So that when we make a change, we make sure that what we did will not actually change the behavior of the program. Well, executable specifications can be written in the form of assertions. So here's one example. Let's assume that you have this code, right? This is pseudocode, not given in any programming language. Let's assume that we have this code which is supposed to move this ball across the screen, right? So it takes as input the distance that the ball should travel, as well as the time that it should take for the ball to travel this distance. Then what it does is that it computes the speed of the ball and do whatever necessary to move that ball across the screen, right? So here is one executable specification in the format of assertion. It says that, well, at this point, time should not be 0. Why? Because I'm going to compute the speed by computing distance over time. When time is 0, the program will crash because division by 0 is undefined. So here we go, assertion, to make sure that at this point of the execution, time is not 0. Why is this important? Because that assertion basically implies the assumption of this code base. Right? By taking a look at this assertion, you can immediately tell that, well, okay, this code assumes that time should be different than 0. Which is important, right? Because it will help, this is a documentation, right? It will help you understand what the code does. Another point is that you can turn on these assertions, you can turn on and off these assertions at will. So for example, you install something at the museum, or you change the software system for the purpose of preservation, and you now want to verify your changes, you turn on all the assertions and run the artwork. If one of those assertions fails, that means that you made a mistake. Go find which assertion failed and fix it. Another form of assertions, another better way of specifying executable statements or executable specifications is to use design by contract idea. So that's another approach that we frequently use in software engineering. So here is the idea behind design by contract. In this approach, when we ship a piece of code, we ship it with a contract. It's a two-way contract. On one way, that contract specifies what the user of this code should expect from the code. On the other hand, it specifies what the code is expecting from the user. These are executables, executable statements, specifications. So here we go, going back to our running example, moving the ball across the screen. So here is a contract. Take a look at this statement. It says it requires time should not be 0. So this is what the code expects from the user. Take a look at this ensure statement. It basically says that, well, if this condition is satisfied, I guarantee you that I will move this ball at a constant speed where the speed is computed like this. And here is an invariant which states that I will guarantee you that through the movement, the shape of the ball will not change. Right? This is like precondition. If that precondition is satisfied, I'll guarantee you that. And when I'm doing that, this will always be true. These are executable. You install the art. You install the art at the museum. You change the software system for preservation. You turn on this contract. You say execute the contract, and if the contract is breached, you get notified right away, so that you will know where you have the failure, which part of the system failed. Well, obviously, these are like somebody has to write them, right? Which can be error-prone, which can be difficult, which can be tedious. But fortunately, we have dynamic programming analysis approaches, which can automatically discover the contract for you. Right? So, for example, given this ball moving across the screen, these approaches, by analyzing the data collected both from inside the executions and outside the execution, these approaches can infer the fact that the ball moves at a constant speed, can automatically infer the distance traveled by the ball, the time that it took for the ball to travel that distance, together with the fact that the ball is a circle and the shape of that ball does not change throughout the movie. All those things can be automatically discovered. So this contract can be automatically written, so that when it is time to change, we can run this automatically discovered contract against the modified version of the artwork to see whether everything is expected or not. We talked about preserving the digital art, but unfortunately it looks like it is not just about preserving the art itself, we should also preserve the environment that the art lives. So here's an example. So let's say that I have a digital art and it requires some web pages or web servers. The art is running in Istanbul, it requires a web server in Japan, or a web page in Japan, right? So in this case, it is not just about preserving the art. We should preserve that web page or web service also. However, we don't even have the binaries for those services, right? They are geographically located at a different geographic location, right? So the thing is that, I can preserve the art here, but without preserving that web service, it will not have any meaning, right? I should preserve the web service too. However, I cannot do that because that web service is like running in a server and I have no control over that server. I cannot simply copy the web service because I don't know the source code, I don't have the binaries. One thing in such cases that we can use is to mock the environment. That's what we call mocking. Well, in this case, what we can do is that we can create a mock environment. Well, in this context, a mock object replaces an original object. And it does nothing but simulates the original object by replaying previously recorded interactions. So from outside, a mock object will look like as if it was a real object, but it is not a real object. What it does is that it simply replays pre-recorded results for us. So here is how mocking can work here. So we have this web service, right? So here we go. This is our digital art. We're going to create a control layer around the digital art. We run the digital art. The digital art will communicate with the environment like that web service. Right? We capture all the interaction between the digital art and the environment and store all these interactions. Like for every request coming out of this digital art, we're going to intercept it, record the request, we're going to forward the request to the web service will reply, we will intercept the reply, record the result. and forward the result back to the digital art. This is the capture phase. In the replay phase, here's what we're going to do. We're going to run our digital work. Our digital work will think that it is communicating with the environment, while indeed it is communicating with our control layer. There will be no service here. The environment is this. We capture the environment. So here will be our mock environment, simply replaying the pre-recorded interactions for that digital art. Okay? Well, here's a concluding remark. Like I said before, preservation concern is something that should be an integral part of the life cycle of any software-based digital art. And after the art has been created, it should be maintained regularly. And waiting until the age of disappearance of the artwork in this context will be too little, too expensive, and too late. Well, that's my 2 cents, and I know that this is pretty technical, but I hope you got.
Thank you. Amazing. Yeah, we're certainly thrilled by your remarks. I think you solved so many of the problems. Thank you for that. But anyway, let me also take Patricia on stage, and we have like 15 minutes for the Q&A. Please address your questions to our presenters.
Yeah, it is.
So when you talked about virtualization, the virtualization process is something that the artist should do, or is the institution that's preserving that should do? So
my point is that it will be too late to wait until the artwork arrives at an institution like at a museum. So it should be the well, I don't want to say the responsibility of the artist, but preferably it is done by the artist. And like I said before, as far as I understand, artists work with programmers or software engineers. It should be done by that side or by this party, right? The programmer or the software engineer working with the artist. Right? It is actually it is actually good for them also, because you have this environment, you don't really worry about any dependencies. Anytime you want, you can recreate those dependencies. It is also beneficial for them.
Are there any artists that have some? I think so. It was really interesting hearing what you just said, because I tend to think of artists as artists, or even their programmers or basic coders. But the interesting thing is what you mentioned here. I have examples of artworks where artists or their programmers actually implemented some of these aspects, not all of them. But so I think it's as a matter of need. So when you mention mocking, for instance, the Brutalismo piece that I mentioned, it actually has a database as part of it. So it's searching the web live, but it's saving it all. Because they had problems with the internet connection and they didn't want the piece to stop, so they dealt with it that way. But it's all in a very, I don't know, maybe I'm not the artist here, so maybe an artist can bump in. It's just the environment in which things are created and whether we want to influence it that much, or how much an impact you have on
The intervention, you mean?
The interaction.
It's sort of.
Yeah, I think all of these principles you presented, Cemal, about how to make software better, essentially, how to make it durable. This is all. I learned a lot from this, and I think it is very good to think about this as an institution rather than an artist, because I know a few artists who work like this. These are like the top of the cream. They have teams of 30 people minimum working for them doing this. And this kind of privileges a certain type of art that is like the big festival art, the Ars Electronica art, and that's and I mean even they don't they don't do all of this, and it breaks pretty quickly. So I think as a software engineer with all that knowledge, what would be a very interesting interaction is to provide options for artists in the form of tools that they can use if they have created something, that they have a choice of implementing some of these, at least, because that would already be a quantum leap. Because at the moment, artists don't have resources, usually. The digital arts is largely an emerging art form still. Because of museums, for example, one of the reasons is museums haven't figured out how to preserve it. So it's like a chicken and egg problem in a way. And so I think the production of tools that embody these principles would be wonderful. Yeah.
Let me tell you this also. So the thing is that, if you take a look at the software engineering projects, right, the managers are not supposed to be technical stakeholders. They do not really necessarily understand the complexities involved in the implementation, right? So what they do is that we have this field called software governance. So what it does is that for non-technical managers, we try to explain the value of each and every source code line. Because they're non-technical, they don't understand the concepts, they don't understand the technology, they know nothing about the programming languages, but they want to see the value created by a piece of software, right? And we have tools and approaches to do that. Well, in the context of digital art, the artist can play the role of a non-technical stakeholder, like a non-technical manager. Well, I'm from a...
I agree.
But
I
we have...
agree with Dragan. You do have some big studios that are working at this level. I think most, I'm taking this for beginners class in open frameworks, and my colleagues will eventually be artists themselves. And if you think, you're creating in I don't know, it sort of feels difficult if you have one or two people that they're doing their thing. And they're not specifically interested in the software itself. They just want to achieve something that it's done. And that's part of their context. I don't think that as an institution we could say we won't buy this unless you redo everything according to these standards, for instance. I mean, we can have conversations, but for instance, I'm always very, very cautious about how much time I ask of an artist in this process. So at the acquisition point, for instance, I feel that we will be paying a hopefully fair amount of money for a piece. So I think it's fair to ask some of their time to do a few things that will make or to do what is necessary to make the work more sustainable. But for instance, coming back in a couple of years again, and I guess that is another system. We can also pay some money for that time to maintain something sustainable. But it's sort of how much do we want to interfere with that context? I think educating people, and providing with the information is good.
So here's the thing, I talk about a, really, bunch of stuff, right? Well, they're not there. I am not saying that everything here must be implemented, right? So, at least people should be aware of this. And when they're doing risk assessment, for example, as museums, when you guys are doing risk assessments, you can use some of these ideas, right? Like I talk about software metrics, right? By having software metrics for preservability, it will give you an idea right away. You don't have to do the manual work, right? It will tell you, oh, this depends on this, that depends on that, and so on. And another good thing about that approach is that once those dependencies are reported, are figured out, then I'm speculating, but crawlers can be created, and we have that as a matter of fact. We have technologies watching whether newer versions of certain libraries are published or not, right? So you can automatically watch for the landscape, to decide what is changing, and you can automatically assess what is, how those changes can affect my digital artwork that I'm maintaining, right? That I'm storing, right? These things can be done. Right, but this is like the realistic picture, But and for the artist, it all depends. There is a trade-off, like I said before. There is a trade-off because I'm an artist. I can say that I don't care about this, which is fine.
Yeah,
but
it's the same way actually.
Right.
Yeah, during the creation progress. Thank you. I mean, if the artwork is commissioned by the museum or by the collector, maybe you can handle the progress from the beginning to the end. You can say, it's going to be good if you can make it in a preservation way, blah blah, whatever it is. So, but it's impossible, I think, because if you are an artist, the artist is thinking in a very different way while creating the artwork.
Sure.
Even if it's digital or canvas, whatever it is, his mind or her mind is just working in a poetic way. I mean, he or she doesn't think about what will happen in the future, when something is happening in a bad way. So, as I said, if the artwork is commissioned, we can include the progress.
Right.
As a museum departments or conservators like that. But what you say is an ideal world, but right now I don't think we are in an ideal world like that. Maybe we are becoming like that actually, because the new media art is more than before right now in the world. So maybe it's going to be different. I'm sure it's going to change, but when you say the artist should preserve the artwork and should think about from the beginning to the end how we preserve the work, it's just a little bit, I think, dreamy.
Okay, but here, let me make this.
As a conservator, I'm saying this actually because I'm working in a museum at Bursan Contemporary. Our artworks are mostly actually new media arts. We have Rafael Rhizome Hammer actually at the same time in our collection. So we are experiencing this kind of things actually very closely. I mean, the artist doesn't think about preservation progress. Mostly.
I completely agree with you, and I understand that is the case in practice. But here is my point: I'm not saying that all these concerns must be addressed by the artist.
Yes, of course.
And I'm pretty sure that probably none of them will be addressed by the artist, right? What I'm saying is that but the artist should be at least aware of these things, and when like I said at the very beginning, I said that I assume that the creation of the artwork involves the development of a piece of software. So in this context, I assume that the artist has some technical perspective, has some technical knowledge. I assume that, and then, but I am not saying that all those aspects will be addressed by the artist. Maybe it is the developer working with the artist. Maybe museums can start programs like certified digital art developers who are all aware of these techniques. Well, I'm speculative. I'm brainstorming, so this is good.
Can I have a few words?
Universities can do that.
Well, universities, there could be programs, right? We have game programming programs, right? Why don't we have like software engineering for digital art, where we teach all this stuff to those things, to those developers?
Yeah. I mean, to
Right.
be fair, actually, what came to my mind is there's sort of these two big frameworks used by artists called processing and open frameworks, where they are frameworks developed by artists for artists.
Mhm.
And
Okay.
it's sort of, if people are working at that level, because they are very common at this point, is how much can you embed in the tools themselves to make things more preservable? You know, is that a point where you could interact with people? And also, to be fair, I don't know other art schools, but for instance, the computing arts program at Goldsmiths, they do learn how to use GIGs, and that
There you go.
so I think if there is dedicated studies in these areas, the students that are learning in that context to have maybe not, you know, a very deep knowledge of best practices, but they will have sort of the average
Right.
knowledge.
Right. So the thing is that when it comes to you know, how much an artist should invest in this, well, it is up to the artist, because there is a trade-off. You know, okay, artist wants to be creative. I understand. You know, this may kill the creativity. I understand that too. But at the end of the day, the artist should also consider, you know, how much she cares about the preservability. Right? If it is a big concern for the artist, well, one way or another, you know, he has to pay attention. If it is not a concern, you know, well, I do my job, you know, I'm a performer, you know, after I'm done with this, I don't care whether it will be preserved or not, well, there is nothing we can do, right? So that decision, how much the artist cares about preservation, should be given by the artist. Well, but I cannot do anything. He cares about it. Well, this is the way to do that. If he doesn't, well, let it be.
Can I have a few words on this? First of all, it's a really nice picture, like people looking each other and trying to come up with who's going to be responsible for that.
Yeah.
I really like that. Yes, everybody's kind of refusing the whole thing. But perhaps a comparison might have, while we're considering a painter, when they paint, do they think about how to preserve it for the future? Perhaps then there comes in an expertise whose job is to preserve that art piece. Are we talking about a new definition of, let's say, if the theme is about digital art, a conservator whose job, whose expertise is this digital art preservation, needs to be equipped with the framework you have mentioned in your presentation. Perhaps we're talking about a definition of a new expertise.
Yeah, possibly. Possibly, because it is important, it is relevant, it is real. So
because as you mentioned, like the artist would create it with, I mean, if the one thread is, I think, as I am observing from the colleagues, the artist would never want to be like trapped and then being under control of so many of like different rules and procedures. But when they come up with the idea and when it turns out to be an artwork, perhaps there has to be an expertise who would keep it to survive for long. Yeah.
And museums can play a role educating the artists as well as, you know, that's.
I mean, I agree with you that if you're collecting something, then you're responsible for caring for it, learning about it, and, you know, as far as possible, work with an artist to make the work more preservable. But when an institution comes to something, it's usually after the fact, so it's already done.
Yeah.
And even if you can make some changes, it's not going to be the whole power. Yeah. In principle, it's not going to be the whole system. But part of the digital art that is being collected is minimal. I mean, Tate is a massive collection, and you've seen the graph, right? So there's thousands and thousands of digital works that are with artists only, and some, you know, we've lost thousands and thousands and millions of paper documents. So it's probably fine if we lose some of them, but if a few of them are kept, then it's also by the artists themselves.
Let us begin. We're delighted to have Dragan Espenschied now. He'll be delivering his talk on, the title is called From Collection to Repertoire. Let me introduce him to you. He was born in Germany, a home computer folk musician. I would love to hear more about that. Net artist and digital culture researcher. And since 2014, he has led the preservation department in Rhizome. In this position, he established emulation, web archiving, and linked data as institutional practices and developed new approaches for preserving and presenting works of net art online and in gallery space. So please welcome Dragan.
Thank you. First of all, I want to say I'm very delighted to be here, and it was it's always great to be invited at a point where where something new is about to happen, and we are not discussing like on some other places where digital preservation or digital art is like where everyone already thinks they have figured out everything, and we are just discussing what version of XML should be used for this or that thing without even thinking, is what we are doing actually productive or right? So I'm very much delighted to be part of here like something that feels formational. Okay, I will not talk about home computer music today, but I want to just speak about Rhizome, which is the institution I work for. So Rhizome is a digital arts institution that has been founded on the internet in 1996 as a mailing list by internet artists. And already in 1998, a program called Artbase was introduced in order to give the art form some more establishment, basically. It was an open accession archive where if someone would feel that they would be an internet artist, they could submit their work, upload it basically to the Artbase, and then there were some very simple formal criteria if this would go into the Artbase, and like that the collection grew very quickly. So when I started my job in 2014, I was faced with a collection of more than 2,000 net artworks. And so this probably also will explain some of the approaches that I thought I need to develop that are different from a museum, for example, that deals with a dozen digital artworks and not net artworks. So, and on top of that, in 2017 and 2018, Rhizome launched the Net Art Anthology, which was a 2-year project where every week the history of net art from our perspective was told, with one piece being presented online every week, which means like 50 pieces per week, per year. And it meant that we had to be, many of them required preservation action just for being able to be presented again. And that means like we had to develop a pace and a rhythm for preservation on top of the large amount that was there. And I have to say, while it was sometimes a bit stressful, it was also extremely productive, all of this. Okay, so I'm also mixing in a few live websites here, which is, so this is the website, and you see of the Net Art Anthology, which ends with the final piece here. The art happens here. It is also important to understand that Rhizome is an organization that, while we appear in gallery space from time to time, we are basically an internet organization, a full-on internet organization. We work in a distributed team at different parts of the world, and we take the internet as an exhibition and collection platform like super seriously. So these are the 100 works. Each of them has its own site with reenactments or documentation or things like that. Okay. So this was the exhibition at the New Museum in New York with which the Net Art Anthology project concluded in the beginning of this year in January. And I want to talk about a few of the pieces that show the preservation approaches that we have developed at Rhizome, of course, together with all of the other people that I will mention in the course of my talk. I want to talk especially about these here. There are two pieces here shown in the same manner. And for that, Starry Night by Mark Tribe and collaborators, which was created at the turn of the millennium, and is it was a website that would give an interface to Rhizome's mailing list archives in the form of a star map with constellations, and the constellations would form along the topics of the email list conversations. And that project was, when I started, it's like one of the precious items in the collection, and it was broken to the biggest extent, and I thought I would never be able to bring it back. But by combining a few different approaches, it was indeed possible. I mean, the worst thing was probably that this was not developed along any of the guidelines that Cemal has outlined. It was a mixture of 4 different programming languages, a pile of code where you didn't really knew which one was used by the artist in the end and which is just dead code. Source code was missing in many places. But the worst thing was that, of course, Java, although it's like write once, run anywhere, the Java applet didn't work at all, and the emails have all been deleted. I mean, this is Rhizome's emails, and they have been deleted during the course of, I don't know, some error that happened before I started. That's what I want to say. It wasn't me. But what is important here is that the same thing that is presented here online on the NetArt anthology is exactly the same software that is presented in the gallery. So here I'm connecting to an emulation framework that runs on Rhizome's infrastructure. This is EAAS, Emulation as a Service, a project by the University of Freiburg originally. And it encapsulates, as you have seen, there's a Windows 2000 computer booting up. And it's connecting to exactly, it basically abstracts these things that Cemal has shown, like with hardware, operating system, and then artifact. It abstracts and encapsulates them. There is also a simulated network environment here that embodies the mock principle that Cemal has introduced. And I can now look here at these emails and say, this is the topic of NetArt, so I can take, for example, a virtual reality post here. Oh, no. Now I'm switching to virtual reality. This is how I would read a message. And so this is all coming from a mock of the emails that have been deleted that were hosted on a web server, but now I can access them like this. So I can also here switch to the topic of video and go here. And this is a piece that's basically 20 years old. And this has been brought back. And it's the same in the gallery. So when I'm going back to my presentation here, you see what we did here is also we used a standard computer that doesn't do anything special, but the emulation framework runs on there too, and we just connected a contemporaneous screen so that the look of the stars is like imitated. But it's not critical. We could also use another screen for that. Okay, and this technique has actually been developed for the first time it was shown at the Haus der Elektronische Künste in Basel, Switzerland, for the exhibition My Boyfriend Came Back from the War 20 Years Online, where we first, which was already, it was technically not that elegant, but the principle was the same. We also used contemporaneous screens and a contemporaneous mouse that even had a ball, but in fact it was going to like some standard computer. This computer here we got as a theater prop just for the atmosphere. It doesn't do anything. Also, it means like when teenagers come to the gallery and turn off the computer, nothing happens because it's like the computer is somewhere else. As you have seen here, in that setup, we took care that it is clearly expressed that this is a recreation and emulation project. So we didn't, this is on a plexiglass stand. In other instantiations of the My Boyfriend Came Back from the War show, the tables were made of glass and the emulated computer was below the desk. Okay, and so I want to quickly also explain how do we conceptualize objecthood in NetArt or in networked software in general. So with a classic archival approach, or sometimes also with the classic art preservation approach, you have the idea that the object and the artifact are kind of one. For example, in document preservation, in digital document preservation, you would think there's a Word file or a PDF file, and that's the object. But we think about it that there is an artifact, and that artifact is basically the state of everything when the computer is turned off. That is like the thing that is still there when the electricity is gone. Then there is performance required, and that's the performance of the computer. The computer has to do things to these artifacts to then create the object, and the object is only that what actually makes sense, what you can interact with. So this is also basically on Cemal's layer model. We would say all of this is maybe the disk image and the software in the turned off state, but the object is only there when you actually see, let's say, this starry night on the screen. So, and that is where we go above storage, basically. So this can be stored, this cannot be stored. And that puts net art, or actually a lot of digital art, into an in-between space in between fine arts and performance art. So on the internet, you encounter certain artifacts and objects, and you interact with them in a certain way. So there is something that is stable, and there is something that is performative. Something that doesn't have any type of embodiment as an artifact or object in a computer basically doesn't exist, because all a computer is doing is making copies like all the time. So there is never nothing there. And this is, I think, also an interesting idea about the question that was raised here before, like how do you agree with artists to make copies? As soon as you start up a computer, like 5,000 copies of everything are made. It's copied from the disk into memory, from the memory to the browser cache, from the browser cache to, I don't know, your backup drive. It all happens automatically. You can't do anything about it. So the artifactual part is definitely there, and the performance part is definitely there too. So when thinking about this, how would we say an object is preserved? So what is like the goal? And I put this in quotes because there's never a state when an object is just preserved. I think you got the sense from that from the previous speakers, but rather like, what is the state that we want to bring an object into so that we can handle it? First of all, the boundaries need to be defined. This is more difficult than it sounds, because when you think, oh, I have this object, and I see these stars, and maybe there's a description by the artist, and that is the artwork. But very often, and especially with net art, it is kind of also the attractiveness of the artwork that the boundaries are not really clear. And when that's the case, like for example, one of the examples would be the Brutalism piece that was shown before from Tate's collection. Is it makes connections to the internet, and there's Google there, and like that's good that you don't know what's coming back. That's like part of the artwork. So there is a blurry thing definitely going on there. But sometimes you at least have to have a strategy in mind. What happens when Google goes away? And this has like happened to hundreds of net artworks. For example, Google's API calls in the beginning were all free. You could just use them, and now you have to be a registered developer and pay them. And if you have like 100 net art pieces in your collection that do Google API calls, then you're thinking this might cost a lot, and we will need to change all the code and all these things, right? Okay. Then second, what you have defined as a conservator, as the boundary of your object, this has to be embodied by artifacts. And a special type of artifact is the environment. The environment is the computing environment that would bring this back. Sometimes it doesn't make sense to store the computing environment at the moment, because if you would put it in a virtual machine, let's say, or if you would put it in an emulator, it wouldn't perform as it should, and it would historicize the piece. Many artists, digital artists and net artists too, work very media specific. So they make works that work the best in some original environment that everyone knows, like Instagram or so. So when an artist does a performance on Instagram over a few months, it is not, they will not be able to like hand over Instagram to you or give you their iPhone where you would scroll through this. This is then more for a historical context. But still, when you think about it, you have to think, is the environment that this is made for, is it there? Do I have it? Or does everyone have it and I don't necessarily need to take care about it right now, but in the future? So if everyone has Google Chrome on their computer, then I don't need to provide Google Chrome. It would actually be increasing the distance in between the viewer of the artwork and the artwork. But at some point, I just have to do it, and that's a trade-off that has to happen. Then third, the performance of the artwork can be reproduced. This is actually a take on the significant properties, because I'm having like, I'm really from a different background, and I kind of have an issue with this term, that there is something that is actually in there that you can, I don't know, pick out and say, this is what I want. It is more like even the definition of what that is can be very mushy, because, for example, I worked with the Transmediale art collection, CD-ROM collection that has like 300 pieces of CD-ROM art from, again, the 2000s. Many of them had instructions with them, and none of them said you need a mouse. Because that was clear. Why would you even write that down? Everyone has a mouse. So there are many things today that we are absolutely blind to because they are so normal. The most normal things are the hardest things to describe. And so if the performance can be reproduced, that means like in the environment that I think are the target environments of this, there are certain things that I want to happen, certain interactions or processes that I want to enable, and these should be there. And usually this is made possible by having the software, having the environment, having the data. Sometimes it can be like impossible to test if your emulator, for example, itself has a bug. This can sometimes only be even, sometimes even the creators of the artwork would say, oh, this works fine, but then if you go to the screen number 9000 in the piece, there might be a pixel of a difference or so, but you know, I don't care. It's not that I don't care, but I think this is definitely a trade-off that can be made, especially when you think that NetArt has always been not made for one like canonical installation, but users would encounter it on their computer that might be a Windows computer, a Macintosh computer, that might have a big screen, that might have a small screen. They might see it in a cafe with headphones, or they might hear the sound, they might not hear the sound. They might be expecting something because they think it's a game, or they might expect something else because they think it's art. So there is a lot of variability in there. Okay. And fourth is portability, and I would even leverage that up to fungibility, so that, and this is why I showed the Starry Night example, for example, is that the only thing I need to worry about with the Starry Night example in the end, which was a tremendous effort to collect all the data from backups, like the emails, the backups that someone had by accident, then changing the star data so that it doesn't point to stars that we don't have emails for and all these kinds of things. In the end, I never want to think about that ever again. So yeah, I want to keep it open so that if I find more emails, that I can include them into this. And this is also how this is constructed. So you need to think about what parts do I want to keep moving, but also what do I not want to think about anymore. And for example, I don't want to think about how Windows 2000 works. Even Microsoft doesn't know how Windows 2000 works. So how would I know? But it is definitely possible to run this on the web, to run this on a local computer, like on my laptop, and to run it in a gallery. And that's what I think is the main goal of all preservation activity in the digital space, is like you reduce the surface that needs to be maintained. You package as much as possible. You abstract as much as possible. Without, I mean, keeping in mind the trade-offs that might happen when how this might affect the artwork in the end. So for example, in the old days of Starry Night, I would go to Rhizome's website, hit the link to Starry Night, the Java applet would start, which might take some time, but it doesn't take as much time as Windows 2000 now takes to boot up in my browser. But I mean, that's definitely a trade-off that I like to make. Okay, and we also published a book about the NetArt ontology, where in the end, every single work in there has a preservation matrix with the abstractions that we developed, like what preservation activity was conducted on each artwork. And for some of them, it was also just, there is nothing left of this anymore. We only have pictures in books or VHS video where someone filmed how it looked, and then that's the only thing that we can present. But otherwise, yeah, there's always these examples here. Now I need to look if I didn't miss any link on the way here. Oh yeah, sure. I wanted to show here how my boyfriend came back from the war is presented online, which is another abstraction layer, as you see. This is just a browser, and this browser is running in a container. So in order to, as I learned now, to loosen the strength of a dependency, we thought, like, if we don't really need Windows 2000 or Windows 98, let's not deal with it, because that's just making things more complicated. It increases the startup time and everything. So this is a Linux container that contains nothing but a wine. I mean, for those who know about that, that's like an abstraction layer that makes Windows programs think that Linux is actually Windows. And it's good enough to run Netscape 3. So here we are. And this is also running from the artist's server. The artist didn't give us a copy of that piece. But, and this is something I will talk later about, like ownership, ideas of ownership. The artist has her server configured that it's maximum 3 kilobytes per second. So this is imitating the loading speed of that project in 1996 when it was created, because that's important for the rhythm. So that's also another thing that you can turn. So, and this is really a collaboration. So like Rhizome has the capabilities to run the old browser. The artist has the artwork, has also some capabilities, and we work together, and in the end, this is the presentation. Okay. So, now boundaries, this is my favorite topic. I'm so sold on boundaries. I could, and I will talk about boundaries. So, when dealing with internet art, we have several degrees of boundedness of a thing. And I definitely see any digital artifact, I see it as software. Because if you think like, is an HTML file data or is it software? It's like very unclear, because you can put JavaScript in there. In a Word document, it's data. It looks like a nice, funny data piece that you move around, but it can have lots of viruses embedded in it, for example. So it's also software. Everything is software for me. So boundary, when a thing is fully bound, I use Microsoft Word. And the old version of Microsoft Word, like the version from, this is, I think, from Windows 3.11, the icon, because you get it on a CD-ROM at that time or on 20 diskettes. You copy that full software on your computer, and everything that the software can do is available on your computer. This is the same for an operating system that doesn't do any activity with outside detachable media or network traffic. Then second, there's a blurry object. The object is partly here and partly who knows where. I use the QuickTime player as an example. This is QuickTime 6. I use it because the design is so ridiculous. It's to remind everyone that Apple was tacky and is still tacky. It's not like so. so what QuickTime is doing, it gives you an install program like QuickTime install.exe. You double click it, and parts of the player are on your computer, are installed on your computer. But anything that you want to do is connected to or is dependent on the existence of certain services on apple.com. And of course, Apple long have discontinued support for this software. And so even if you have the software, it cannot perform all of its functions. So there was a very techy drawer here that you could draw out, and you would have certain channels. It was like a very early Netflix, you could even say. And you could pick what you want to watch. Of course, you pull this drawer out and it's empty, or you're getting error messages. This is just an example. This is not necessarily relevant unless an artist hosted their video with Apple QuickTime. But I hope they would have a copy of that in another way. The same is with actually one of the most important pieces of software for internet art, which is Internet Explorer 6, which dominated the net for almost a decade because Microsoft had this huge monopoly on Windows XP. And this is blurry software. You can download it, but it tries to download the rest of its components from Microsoft, and it's not there anymore. The way to get Internet Explorer 6 today is getting an edition of Windows XP that has it fully integrated like the version that you want. Otherwise, the software is lost. I know there are like government archives where you can get it, but also like if it's easier to get it with the complete Windows XP, that's fine. But for example, it doesn't run in a container. It needs the full Windows XP. And then there are fully boundless objects. That's like, I used Instagram here. Artists work with Instagram. Instagram is a thing in a way. It's an artifact that you encounter, but there is no control that anyone, apart from Instagram themselves, have over it. And even if I would have the power to ask Facebook, can I get a copy of Instagram? I'm not sure if they would be able to give me one, because it's a constantly evolving system, and they do A/B testing on it. Like some users see one interface, other users see another interface. And then they figure out on which of these designs users click on more ads, and then they run with that one. So it is in itself like very hard to define a boundary on it, and you will never get any control over it. Okay, so what type of artifacts are resulting from these levels of boundedness? And I want to, this is like going to this concept of the mock. Sometimes you can work with a fully performative system, but then there is like a sliding scale where you move into documentation, and it doesn't have to be a clear cut. For example, web archives are like very much in between. If you create a mock service, if you create a mock Google search, that is like very close to documentation, but it's not actual documentation. It's more like, this is how it used to be, and we can recreate it, but it's not the real Google. But it's also not nothing. So, software environments, and I want to now give some clear examples of these artifacts, but in reality, you use them all the time in combination and with different techniques. So, one of my favorite software environments is, there's now, I'm sorry about this. This should be much smaller. There's you see the black space is too big. I'm sorry about that. But here, this is the piece IOD by IOD, IOD3, which was a group in Great Britain who would distribute software art on diskettes and bulletin board systems where you could download the software. And this here is this also comes with an installer, and the installing process is part of the artwork. So they were one of the first that wrote their own like licenses that are totally crazy. So if you read them, they're pretty funny. And so I'm installing something now, and you see here this is just empty folders that are in empty folders, and the names of the folders and the arrangement of the windows on screen forms a poem about what happens in the computer. And it's compared with Dante's Inferno. It's a very beautiful piece. But if you think about it, would I just take these files, like these folders? Can I just store it in that way? Of course not, because only this version of the operating system has exactly that feature that every window can have its own coordinates, and you see its own size. And yeah, you see it's pretty dramatic. It's like you're going through a theater performance, and this is the stage, right? There's even a place where a window opens that have 2 folders, and then you can choose a path. That's the most exciting part. Okay, so, but that's a fully contained computing environment with the data basically being in it too. This is a, let's say, software environments. Oh yeah, I knew what I wanted to do. The second is containers. Containers, we see them also as like an interim step before a computing environment needs to be moved into an emulator. We use containers especially for software that needs to run on a server because it's extremely cheap. You can basically run like 50 containers on a single server, and as long as not everyone wants to look at all of the containers at the same time, it's fine. And I mean, we are dealing with art. This is not Instagram, so it usually works pretty well. So this is a container for a piece of critical writing by, oh, I'm sorry, I forgot the name of the artist. I have to quickly look up. That's embarrassing. Here. I'm sorry. Here. Jean McHugh. Okay, sorry. I hope this is not streamed, and I hope Jean doesn't see it. So, this is a WordPress blog, WordPress version 1 point something, I forgot exactly what version it is, that used to be online. It was put online on the 29th of December 2009, that's the URL, or that was the name, how it was hosted. It was 122909a.com. I think the A is just because you can't have a domain name that only has numbers in it. And this blog was turned off. There were some fragments of it in web archives to be found, but the whole texts were published in a book. And so what we did was, from these fragments that were on the web archives, it was easy to see this is a really old version of WordPress. Also, we know when the blog was started, and the point of the artist was basically, I just use everything default. I make no customization. So we used an old version of WordPress, put it in an old version of a server, and put that into a container, and then basically pasted the text from the book back onto the blog where it originated. And from what we found on web archives, we could basically reconstruct the tags and the sorting and everything. So now it's also possible to search this again just as it was. It's a reconstruction, but again, the idea is I want to only do this once. I never want to do this again. So it's in a container, and it's also very easy to move a container into an emulator should that be needed. But we don't do this unless it's needed because, yeah, emulators are more expensive. They need more CPU time. Okay. Then web archives. Oh yeah. So these are things where we get into the blurry directory, blurry direction. Here, and I want to talk about this tool a little bit too. This is a tool that Rhizome has developed on its own, which is called Web Recorder, which is a web archiving service and whole software framework with a focus on art. However, it has been adopted by traditional archivists or national libraries or things like that too. And so quickly to describe why I web archived this. So Mediengruppe Bitnik is a group from Switzerland that is doing like very interventionalist action online and anywhere where, I don't know, electricity is involved basically. They published a book with this title, Script Alert, open brackets, Mediengruppe Bitnik, bracket close, script close. That is a very small snippet of JavaScript that a browser would execute. The browser would show an alert box that says Mediengruppe Bitnik. So the idea was they named their book like this and see what happens with book traders, book merchant websites. So I want to show you what happened back then. Here, Buchhandlung Walter König. This is like a very, this is a very nice. You see, oh, okay. So on the day when the book was published and appeared on these sites, I went in with Web Recorder and captured the pages. And you see here, it says Mediengruppe Bitnik. Mediengruppe Bitnik, because the Buchhandlung Walter König just put the title of the book into their web page. And that means the script is executed. Let's see here, there's also Saxo, Mediengruppe Bitnik, yeah, Mediengruppe Bitnik, Mediengruppe Bitnik, Mediengruppe Bitnik. And you know, when the alert is open, you can't do anything on the page. So that was like part of the hack. Or of the like intervention. And you see here now, the things appear bit by bit as all of the scripts need to be executed. This is like so many times. I'm not sure.
Every time the title is on the page.
Yeah.
That's how often it
Yes, yeah. And this is especially nice if you're searching for something and you get a search result page and Mediengruppe Bitnik is like at the very bottom, you don't even see it. It says Mediengruppe Bitnik like all the time. So this is very beautiful. Of course, yeah, I love this, yeah. So this is, for this to work, I basically need this is how the software of these bookshops is written. It has not, they never thought about the fact that someone could name a book like that. And so it doesn't do any security measures against it. And what in the end happened is that the title in the ISBN directory of the book was actually changed in order to relieve all these bookshops from this trouble. So nowadays, if I look at this URL, which I see here, this is the URL I visited, this is the date I visited it. If I look at this today, it will look different. So let's compare. So it worked only for a very short amount of time. So you see, everything's fine now, everything's boring. Yeah, I like insecurity. I like bugs. Yeah, so this is, so you see, it is performative. It does things, but it's not the real thing. It's like on the sliding scale, it's closer, it's very close to documentation. It's not a video. This is actually happening. The old code of the website is preserved, but it is not the real website. All the server parts are missing. It's only what you see. And this is how Web Recorder works. It's it sits in between your browser and the internet, and it is exactly this negotiation layer that Cemal mentioned. It sees responses and requests, requests and responses, and then later it fakes them again. Okay. And then I think that's probably for, especially in the museum world, this is something that I think needs to catch on more, which is you can also use public data for your artwork to like consider it for restoration. So here we have this artwork from Heath Bunting, which is a very simple website that he has that documents certain cybercafe actions, and so he's like basically a political activist artist in between. And so we know that this exists. I want to show this here quickly on the presentation again. We know that this exists in a public web archive. The public web archive shows it in in your current browser, so you don't get the feeling that it is old. You don't get the feeling that it's a historical piece. But we can also say we use the framework Old Web Today, which combines web archives with an emulator. And it is set up here in a way that this URL is loaded from a bunch of web archives. It's asking the Library of Congress, the British National Library, the Internet Archive, of course, the Portuguese Web Archive, which is a very good one of the best. And also, do you have this page at that point in time? And one of them will maybe answer yes and says, here, I have this page. It's made of 3 resources. It's the HTML file. It's this graphic. It's this graphic. So these are 3 resources have been loaded. And they are spanning, like they have been archived in between 2001, yeah, like in the course of one day. So this is not necessarily, not necessarily all of this is exact from the same time even. But this is much better than not showing anything or just showing a screenshot, because now I can also use this old browser and walk around in that old website with the old browser. And it will be, the resources will be taken from different web archives. It's an aggregator of public data. All right, here. There are many web sources where you get like 3 or 4 different resources when a single resource, like a single web page, is not completely located in one archive, but the images are there, the text is there, another image comes from somewhere else. Okay, so now, I hope that this was all illustrative about how do you need to think about, or how I like to think about, especially when I have to deal with a lot of objects in a very short succession, that what is really valuable for that kind of work. And I'm always amused by these projects. This is something that, that GitHub has announced. So GitHub is this, an open source code repository where you can put your source code in and invite other people to work on it. At Rhizome, we also use Git to make versions of artworks when we have to change something in there. So we have a log of source code modifications if we need to make them. But Git is now saying we are putting on this date, on the 2nd of February 2020, any open source code that we have, we will put it into this vault in Norway, and there it will be stored for 1,000 years. And that is, I mean, in this vault in Norway, they usually store seeds of crops, so that if a nuclear explosion happens or something and only 5 people survive, they can come out later and they have the crops and they can grow corn again and aubergines and all the nice things. But this makes no sense for software. Because, I mean, that's also what Cemal said. Once you stop running software, which is a part of maintenance, really, how I see it, if you know how to run a certain software, that's already a big, that's already knowledge. Or if you're able to publish this online, that's knowledge. But if you stop doing that for 10 years or for like 1,000 years, what will come out of this vault is just garbage. Because what will someone do in 1,000 years with my Node.js build chain that is using Grunt or whatever? This is like impossible to manage today. How is this going to be managed in 1,000 years? That's a very, I mean, I think this is very Silicon Valley, a Silicon Valley idea of preservation of digital culture, which I don't know, has a lot of nihilism built in, because like, oh yeah, we are all gonna die, but our software will be in a space probe circling around Uranus or something. This is like, this is not preservation. This is a publicity stunt, right? But how do people come to these ideas? And this is where we really have, as conservators, have to reflect on what is our background and how do we think about computers. Because essentially computers, this is a Xerox star from 1979, where the desktop metaphor was basically invented. It was invented by, this project was brought forward by the same company that created the laser printer from copying machines, from Xerox. And they basically needed a digital system to send bitmaps to that machine so that they could sell it, that you could make really nice, neat documents without a typewriter. And it was their idea that basically the computer should resemble an office with files and folders and all these things. You could print it out on a Xerox printer. It would have the same size as on screen. A lot of these ideas are still embodied from like paper conservation to now to document conservation. Or, I don't know, this is like my nightmare object. This is another idea, like these cuneiform tablets, they have survived 5,000 years. How can we make software survive 5,000 years? This makes no sense. Because, I mean, this says like, this farmer has to pay 5 bulls and 2 sheep to the Lord. But why do we still have this? We have it because it's trash. Any great building that was made of stone from any of the huge civilizations has been dismantled by the people that came after that like civilization collapsed. It was really useful stuff, like stones and other building materials. This was just, you couldn't use it for anything. It was ruined. It used to be soft clay, but then how did they become hard? It was usually because of war, and the archives were set on fire. And I think this is very bad if you think about, I want to make something preservable just as this, that survives the apocalypse. I want to prevent the apocalypse. Okay, yeah, and so like, this is, for some, you have to think, like, do I think that this and this is the same? Structurally, in a way, yes, but if you take the metaphor too far, it is a hindrance in preservation work. And here, this is a piece by Sarah Ludi. It's called Aviary. It's a VR work, and I think especially VR is a good like test for your mindset about what a computer is or what software is. This is a work, a piece that she's been working on since 2017. It's incredibly beautiful. This is I took screenshots from a video documentation of it, and so you're basically in your headset, you're exploring this landscape, there are these glittery things blowing around, there is sound, you can push these, I don't know, beautiful things around and they move. So how would you approach this from the perspective of a sculpture conservator? Would you say, I want to catalog all of these objects and where they are standing? Do you want to think, I will document this as a video, and I don't know, make a documentation about this invented country maybe? Do I think the software is what makes all of this move and puts it together? What kind of abstraction layer do I want to put around it? Do I want to store the headset? Yeah, I mean, when I started at Rhizome, the first thing I did was, we had a collection of old hardware, and I wrote on Twitter, anyone who wants an old Macintosh, an SCSI scanner, and another old Macintosh, please come by. I will present it to you for free, because the decision was the focus will always be on pure software, because hardware, we are too small of an organization. We are just like 11 people, including like 5 people working on web recorder, only, no, 6. And that's, so hardware is just not sustainable for us. Okay, and that means, I hope that, yeah, I wanted to talk about this idea of ownership, and I like that the term care has been used here a lot in previous presentations, but also in discussions. When you think about that, your objects are blurry, or the knowledge required to work with these objects, or to work, or to like draw the right abstraction layer, or even the data might not be yours on the net. It might belong to Google or Instagram or whatever. Then you are switching from owning everything, like to having it somewhere in your like building, maybe even. Rhizome, I mean, we have offices in New York, but I mean, we don't need them really to operate. Should we be kicked out there, we would still exist. so let's say it's on your server, maybe it's not even on your server. It might be that another institution bought the artwork. Let's say another institution would have bought Starry Night. If they would have that email archive that I would need to work with them, maybe we would need to establish a bridge in between them, and they take care of the emails because they want to index them or present them in another way, and we would need to provide the access interface, or we would provide the emulation framework with the browsers, and the artists host their artwork still because it's still theirs. So it's more about a service for the artwork. And it's also it's not necessarily something that you can say, this costs me so much money, and in the future I will sell it for that much money again. It's more the idea that the cultural value is preserved through care, and that care might be distributed too. Okay, that's it. That's my email address.
So we mentioned this sliding scale between the object performed, I imagine, and the documentation.
Yeah.
Did you, when you decided, or for artworks where you definitely were towards the documentation end of the scale, were you discussing that with artists, and do you have a sense of what, is there a sort of a broad feeling about?
This is, I think this depends. What is, in general, I think that talking to artists is a preservation risk in itself, so that needs to be managed. In many cases, it is like how we like, or how I like to work, especially given the few resources that we have, given the big collection, the short time, is that we propose something that is economical for us, that works for us, that does the, that approaches the quality level that we are interested in. We show it to the artists, and then they can get feedback on that. But some artists also say, no, you can't use a web archive. It is important for me that there's actually data traveling across the web from me to you. And then, of course, we can't use a web archive. But that is, in many cases, it's really the case that the work has been lost. We have been able to reconstruct it or dig it up from somewhere in some form, and then artists are usually happy to be able to see it again. So usually or not usually, but what we often have is just screenshots or photos in a book or something. That is how the work lives on, and then from, I don't know, a bunch of Java applets and whatever, we are able to reconstruct it. But that's, artists have different feelings about that.
Thank you for your work, and especially this net art anthology was great to follow for me. But I remember running the emulators or opening the websites. I don't remember running the emulators, but opening the websites. But I remember reading all the information collected around the works, which describes in which context these works were produced, referring to which contemporary phenomenon. Because if you're talking about contemporary art, what makes it contemporary is how it refers to the contemporary phenomenon. And in a networked way, even if we are not talking about networked art, by the way, like digital works, software works, network-based works, they all have different natures, and we all need to consider different aspects for preservation. But what was great about that project is that it made me experience the work, which makes it valuable, because that works were valuable because how they referred to the time they were produced in.
Yes.
And if we look at the great, in quotes, works of art, they were important because of the context they were produced in. Now we can only experience those works through their memories or what has happened after those works were exhibited. And if I think that which works I like the best, they are the works that I haven't experienced. But what preserved them, which made me available to experience the context they open up, was the way how they were communicated through the context around which they were presented to us. So I think before discussing the strategies, etc., to preserve for the works, I think we should first create a preservation policy for each institution. For example, if it's a memory institution which should preserve unique works of art, that's a public responsibility, so that they should follow different measures. But if it's just a private collection that keeps one edition of a 5-edition work, then if the idea is to make that work to be accessible for exhibition in the future, it would be much cheaper to lend the work, another edition of the work from another collection, than to preserve, to recreate that work in that context. So I think we must first understand the nature of the medium we are talking about, and it's the digital information which can be duplicated as it is in a way, so that it can be migrated, etc. So these are all new concepts for preservation of art. So I know it's taking a little long, but I'll try to explain. So first of all, I think an institution should decide what to preserve. Will they preserve what the artist wants to exhibit it in the future, or do they like to preserve the work so that the curator may exhibit it in the future in a different context, in a different way? These are also about the moral rights of the artist. So there are many legal, etc. things to be solved. So I think the most crucial part for starting this preservation is to have interviews with the artist, where the collector and the technical people, etc., should come all together, so that the institution, even if the institution does not have a preservation policy for now, they would create their preservation policies in the future if they have these. And also, I was looking, this is something else maybe, I was looking at the Wayback Machine the day before, and I found that the first capture of Tate was in 1996 by the Wayback Machine, and it reads, this domain is registered by our customer. So it was even preserved before Tate, who is supposed to preserve the culture, it was even preserved before Tate has made and opened the website. And also that website about the post-internet thing, it's also available on archive.org. So
these were the pieces used for the reconstruction. It's incomplete there.
There are also some works which are very valuable in this context. So maybe a strategy for an institution which has a lot of funds could be like donating Internet Archive, so that they could keep on what at least they have, because I believe that we all have the copies of newspapers, etc., but I don't think there are many institutions, or even any institution, which has their previous versions of their websites.
And this is an issue with there are many interesting points I want to discuss. I want to reply to. First of all, the preservation policy and how to create a preservation policy. So Rhizome has been doing this for a very long time. Some people that worked with us were also involved with creating the variable media questionnaire, like Johnny Polito and Richard Reinhardt and so forth. And I have come to a point, but that's really, you have to keep Rhizome's context in mind. And also my previous work for Transmediale, or other rather big accumulations of digital culture, is that the artist interview is definitely a tool, but it's overestimated what it can do. That's my experience. Because you're putting artists in a position, some of them are very good at this, Some of them are not, because if it depends very much on your framework of thought, really, when you ask an artist about what did you mean with this, or how should this be presented in the future. Like the god of media art, Nam June Paik, said, "You can use whatever monitor you want for my sculptures." He never could foresee, of course, that monitors would be 1 centimeter deep today. So how should artists predict that? How should artists predict, for example, I have some like artist notes. We have a lot of those on Rhizomes, and also the Transmediale had some, and they're saying like, this video has to be played in with the browser full screen, and it has to be cropped and such. Like, yeah, well, you are assuming that there's a browser, or you are assuming that the browser has elements around it. There were others that saying, other artists were, not writing that you would need a mouse. I mean, it's very hard to ask this from artists. The old Rhizome art base had a list of browsers that artists should make like a tick. So does it work on this browser? And probably most of them have never heard of like 90% of these browsers. I mean, this is not something that I think artists cannot necessarily make better input about that than a preservation specialist. That's one. And the other thing is that artists need to be very strategic in everything they do. And they would, for example, tell one institution that buys the artwork, yeah, sure, it's a video work. And to the other, they would say, no, it has to be a computer that generates that image. It needs to be real time. And then they meet and they say, oh, well, he told this to us. And oh, he told this to us. It is not because that's the nature of the artwork, but because the artist needs to pay bills and say, okay, they're giving me a lot of money. So I was saying, okay, this is a video work. So yeah, my landlord is asking me for where's the money. This all has to be taken into account. That's one thing. Artists will use this. There's also a lot of power games with very established artists. They make incredibly difficult instructions to assure their importance. That is unfortunately happening. Not so much with net art. Net art people are the best artists, I tell you. Then I really think the Internet Archive is an incredibly valuable resource, and it's a resource that is just going on its own. Many countries have their own national archives and their own national web archiving programs. The most outstanding ones are probably the British Library and the Portuguese Web Archive. But we have created Web Recorder especially for all of the blind spots that these archives have. For the 10th link somewhere in your project where you need to log in, where you need to type in your name and password to get to, which is something that these archives cannot access and what they shouldn't be accessing. This is something that you should be doing yourself. Web archiving has been an activity that everyone thinks you need the experts to do this. Like the bigger the institution, the better. Our idea was we want to enable as many people as possible to do web archiving. And this is why Web Recorder was created. But everything that Web Recorder creates is, again, standard ISO work files. So it could be donated to the Internet Archive. It is just like they don't have a policy that they would take work files from anyone because I could forge them. I could submit a Tate org UK that says, this is Dragan's website, I'm the coolest in the world, and dated 1995 and submit it to them. Of course, they have to be careful what they are taking in. But yeah, I think that what we are doing with Rhizome is that we run our own web archive that is also public, and we are also taking part in like the index of what type of URLs do you have from what point in time. So aggregators like this Old Web Today project that I showed, which is also a Rhizome project, can make use of our web archive and can make use of other web archives. And then definitely, yeah, there should be more web archives.
I would like to thank for all presenters who did amazing presentations and they showed us their insights. And hopefully we'll see you next time. Seems like in December we will have another session of these panels. So please keep in touch. And if you would like to contribute to this project, please be around. Okay, thank you for coming.
Thank you.